Picture the Milky Way as a spinning disk of stars, flat, wide, and packed with light. Most of these stars crowd together near the middle, hugging that central plane where gravity holds everything tight. You would think that our sun lives there too, pressed into that cosmic flatline along with all the others. It does not. Our entire solar system is currently floating 55 light-years above the galactic midline. That is 324 trillion miles north of where the galaxy is at its thickest. Scientists confirmed this measurement by using gamma-ray telescopes that are able to peer through the thick clouds of dust and gas. They have marked our exact position in three-dimensional space. The data is solid. We are not where we are supposed to be. The galactic plane itself stretches for 100,000 light-years across, but it is only 1,000 light-years thick. Think of it like a dinner plate. The sun should be located somewhere in that plate, but instead it is hovering just above the porcelain. It is floating in the emptiness that is between the table and the dish. This strange positioning changes everything about what is surrounding us. Most people imagine space as being a kind of sphere that is centered around the Earth. They think that the dangers and the wonders are spread out equally in all directions. But that is wrong. When you look up at the night sky toward the northern galactic pole, you are staring into a completely different neighborhood than when you are looking down toward the south. The structures are different. The densities of the matter are different. Even the temperature of the invisible gas differs between these two directions, though scientists are still arguing about why. Being above the plane of the galaxy means that we are experiencing less of the radiation that is coming from the galactic center. That supermassive black hole, which is 4 million times heavier than our own sun, is sitting 27,000 light-years away. But it is also below us in that dense stellar disk. Its violence gets filtered through the layers of gas and stars before it is able to reach our floating position. Some researchers have suggested that this elevation is what protected the Earth during its early years, and that it allowed life to be able to develop without being scorched by an excessive amount of cosmic rays. But here is what makes the astronomers a bit nervous. Our position is not a permanent one. The sun does not just stay at 55 light-years north forever. It moves. It oscillates. It swings up and down through the galactic plane like a weight that is on a spring, and it is crossing through that crowded stellar disk again and again. We are currently moving away from the plane, and we are heading farther north at a speed of about 4.5 miles per second. The last time that we had crossed through the galactic plane was 3 million years ago. This was right around the time when the early humans had started to walk upright in Africa. The next time that we will cross will be about 30 million years from now, assuming that nothing massive is able to knock us off of our course first. Each of these crossings is taking us through the denser regions of space. It is taking us through the clouds of gas and the gravitational chaos that could disturb the frozen comets that are orbiting at the very edge of our solar system. And that oscillation, that cosmic bobbing motion up and down, is happening because of the forces that you cannot see. They are pulling on us from both above and below. These are forces that never stop. They are forces that are treating our own sun like a toy that is on a string, and they are yanking it through the different layers of the galaxy, whether we want to move or not. So what is causing that pull? The answer to that question is even stranger than you might expect. Imagine dropping a ball through a hole that has been drilled all the way through the center of the Earth. The ball would fall, and it would pick up speed, and it would shoot past the center, and it would keep on going all the way to the other side. Then the force of gravity would pull it back. The ball would oscillate back and forth through the planet over and over again like a pendulum that is swinging through a vertical space. Our own sun is doing exactly this through the Milky Way galaxy. Every 26 million years, our solar system completes one full bounce up and down through the galactic plane and back again. Scientists have confirmed this rhythm by tracking the positions of the stars and by calculating the gravitational forces that are at work throughout the entire galaxy. The math is certain. We are a cosmic pendulum. Here is how it works. The galactic disk is containing most of the Milky Way's visible mass. The stars, the gas, and the dust are all packed into that flat structure. When the sun is floating above the plane like it is now, all of that mass that is below us is creating a gravitational tug that is pulling downward. Every single star, every cloud, and every particle is pulling us back toward the middle. So we are falling slowly at first and then faster. We are currently moving to the north away from the plane, but that motion is beginning to slow down. Eventually we will stop rising and we will hover for a moment, and then we will plunge back down toward the galactic center line. When we are crossing through the plane, we will be moving very fast, maybe 6 miles per second or more. This will be enough to be able to shoot us past the middle and out the other side. Then the same thing will happen, but in reverse. Once we have emerged below the galactic plane, all of that mass that is above us will be pulling upward. We will slow down and we will stop, and we will reverse our course, and we will fall back through the plane once again, and we will be heading to the north. The cycle never ends. It has repeated itself hundreds of times since the sun had first formed 4.5 billion years ago. But there is something that is making this motion much more complex than just a simple pendulum. The galactic disk is not the only thing that is pulling on us. There is the dark matter. This is the invisible substance that is making up most of the mass of our galaxy, and it is wrapping the entire Milky Way in a halo that is extending far above and below the visible stars. This dark matter is contributing about 15% of an additional pull to our own vertical oscillation. Scientists have calculated this by measuring how fast we are moving and then working backward to be able to figure out what forces could be causing that particular speed. Some researchers had proposed something terrifying back in the 1980s. They had suggested that we are encountering the denser regions of matter every single time that we are crossing the galactic plane, and that those dense patches are shaking the Oort cloud and are sending the comets flying toward the Earth. They had called it the extinction theory. The major extinction events that have occurred on the Earth, including the one that had killed off the dinosaurs, had seemed to be lining up with our crossings through the galactic plane, which are happening every 26 million years. The evidence had looked very compelling at first. Then the better dating of the extinction events had shown that the pattern was not as clean as had initially been thought. The theory had fallen apart under a great deal of scrutiny. But here is what is still bothering the astronomers. We do cross through different environments. The density of the gas, the strength of the magnetic fields, and the intensity of the radiation are all changing as we are bobbing up and down through the galactic space. And those changes are definitely having an effect on what is happening at the very edge of our solar system. The pendulum motion means that the Earth has experienced a wide variety of different galactic neighborhoods throughout its long history. Life on our planet has evolved while the sun has been traveling through these varying cosmic conditions. Some of these periods have been calm, while others have been violent. What is waiting for us on our next swing through the plane of the galaxy? Nobody can say for certain, but the laws of physics are promising us that we will find out in about 30 million years. Unless, of course, something else is able to reach us first. Something that is already closing in on us from the void that we are floating inside of. You are living inside of a bubble that is 1,000 light years wide. The walls of this bubble are made of compressed gas. The interior of it is nearly empty. It is one of the most extreme vacuums that astronomers have ever detected in all of space. This is not a natural formation. This is a crime scene. Scientists are calling it the local bubble. They have confirmed its existence by using multiple different methods, including the X-ray telescopes that have mapped out the hot gas that is defining its boundaries, and the optical surveys that have shown where the nearby stars are. Clustering. Every single star that is within 500 light years of the Earth is sitting on the surface of this bubble, not inside of it. We are floating in a cosmic cavity that has been carved by an incredible amount of violence. The inside of the bubble contains about 1,000th of an atom per cubic centimeter. That is 10 million times less dense than the air that you are breathing right now. For a point of comparison, the best laboratory vacuum that humans are able to create is still 10,000 times denser than a typical interstellar cloud, which is itself thousands of times denser than the local bubble. This void is absurdly empty. But here is what makes it so strange. The gas that is inside of it is hot. Not just warm, but hot at about 1 million degrees Kelvin. Meanwhile, the local interstellar cloud that is immediately surrounding our own solar system is merely warm at a temperature of 7,000 degrees, and it has a density of 0.3 of an atom per cubic centimeter. These are two completely different environments that are pressed up against each other. So how does the gas reach a temperature of 1 million degrees in the middle of nowhere? Only one thing is able to produce that kind of heat: supernova explosions, and multiple of them, massive stars that have been detonating in a sequence. Each of these blasts has been feeding its energy into the expanding cavity, and it has been heating the interior to temperatures that would vaporize anything solid instantly. Astronomers have been able to trace the evidence backward. They have studied the motion of the nearby star clusters, and they have calculated when the massive stars in our own neighborhood would have exploded. The timeline has pointed to a period that was between 10 and 20 million years ago. And it was not just one single supernova, but several of them. There were possibly as many as 15 or 20 separate detonations. Each of these explosions had added its energy to the bubble, and it had pushed its walls outward, and it had swept up the gas and the dust, and it had created the very void that we are now inhabiting. Think about what that means for a moment. Our solar system was already here when those stars had exploded. The Earth had existed. Life had been thriving in the oceans. And somewhere out in our own galactic neighborhood, some massive stars had reached the end of their fuel supplies and had detonated one after another in a kind of cosmic chain reaction. Each of these blasts had sent some shock waves expanding outward at thousands of miles per second. Each one of them had heated the surrounding gas to millions of degrees. The bubble had grown larger with every single explosion, and we had survived it, but barely. The shock waves had weakened as they had traveled outward. By the time that they had reached us, assuming that we were near the edge of the forming bubble, the violence had dissipated enough that it had not destroyed the atmosphere of the Earth. But the evidence is suggesting something that is much more terrifying. We might have been inside of the bubble as it was forming, and we might have been caught in the expanding cavity, and we might have been bombarded by the radiation and the high-energy particles for millions of years. Scientists have recently discovered that we are in the process of emerging from the local bubble. Our trajectory will take us out of this void in the next several million years, assuming that we do not encounter another dense cloud first. But the bubble itself is not yet finished. It is continuing to expand even now, though it is doing so much more slowly than it was during the initial blasts. The walls of the bubble are pushing outward into the surrounding space, and they are compressing the gas at their edges, which is potentially triggering the formation of new stars. And here is the part that should keep you awake at night. Every single star has a lifespan, and every single massive star will eventually explode. The local bubble is surrounded by some young bright stars in a structure that is known as Gould's belt. Some of those stars will go supernova in the future. The crime scene is not cold yet. The killers might just strike again. 15 massive stars had to die to be able to create the space that you are calling home. Each one of them had burned much brighter than our own sun ever could. They had lived fast, and they had exhausted all of their fuel in just a few million years. And then they had exploded with more energy than our own sun will produce in its entire 10 billion year lifetime. These were not distant events. These had happened in our own neighborhood. The best candidate for what had triggered the local bubble is a group of stars that astronomers are calling the Scorpius-Centaurus Association. This collection of massive hot stars is sitting about 400 light-years away from us, and it is right on the very edge of our bubble. The computer simulations have confirmed that a cluster of supernovae in that particular location could have carved out a cavity that is matching the size and the shape of the local bubble. that we are able to observe today. Here is how a supernova is able to create a bubble. A massive star, which is maybe 20 or 30 times heavier than our own sun, is fusing hydrogen into helium in its core. Then it is fusing helium into carbon and then carbon into oxygen. The fusion process is continuing all the way up the periodic table, and it is creating heavier and heavier elements. But when the core of the star starts to be fusing iron, the process stops producing energy. Instead, it begins to consume energy. The core of the star then collapses in less than a single second. The matter is falling inward at nearly a quarter of the speed of light. The collapse is happening so fast that the outer layers of the star do not have the time to react. They are hanging in space for a moment, and they are suspended while the core is imploding beneath them. Then the core bounces. The rebound sends a shock wave that is exploding outward through the outer layers of the star at thousands of miles per second. The star is tearing itself apart. The explosion is releasing more energy in just a few seconds than 100 billion normal stars are producing in the same amount of time. That energy is blasting outward in all directions, and it is heating the surrounding gas to millions of degrees, and it is accelerating it to supersonic speeds. A supernova remnant is expanding like a cosmic bomb crater, and it is growing larger every single year. Now imagine 15 or 20 of these explosions that are happening in the same region of space over the course of 10 million years. Each of the blasts is adding its energy to the expanding cavity. Each one of them is pushing the walls of the bubble farther outward. The combined effect is creating a structure that is far larger than any single supernova could ever produce. This is what is known as a superbubble. The violence is not stopping at the explosion. The shock waves from the multiple supernovae are colliding with each other and with the surrounding interstellar medium. Where these shock fronts are meeting, they are compressing the gas into some very dense sheets. These compressed regions are sometimes collapsing under their own gravity, and they are triggering new waves of star formation. The cycle is repeating itself. The massive stars are forming, and they are living fast, and they are exploding, and they are creating more bubbles, and they are triggering more star formation. Scientists have found some physical evidence that these explosions had an effect on the Earth. The proof of this is sitting in the deep ocean sediments. When researchers had drilled some cores from the ocean floor and they had analyzed the layers, they had discovered some elevated concentrations of iron 60. This is a radioactive isotope that does not form naturally on the Earth or in our solar system. The only known source for it is in the supernova explosions. The iron 60 had peaked twice, once about 1.7 to 3.2 million years ago, and then again about 6.5 to 8.7 million years ago. Both of these peaks are corresponding perfectly with the time when our own solar system would have been crossing through the debris clouds from the supernovae that had created the local bubble. The radioactive atoms had fallen from space, and they had settled in the ocean, and they had stayed there as the evidence. The proof of this is buried in the mud at the very bottom of the sea. And here is what is troubling the astronomers who are studying this. We do not know exactly where the solar system was positioned when those explosions had happened. We might have been near the edge of the forming bubble, and so we would have been relatively safe. Or we could have been much closer to the detonations, and we would have been exposed to far more radiation than the magnetic field and the atmosphere of the Earth could have easily handled. The radiation levels could have had an influence on the mutation rates in the life on the Earth, and they could have possibly been accelerating the process of evolution during those periods. We had survived, but what had changed inside of us because of it, nobody yet knows. Deep beneath the Pacific Ocean and buried in the layers of mud that have been accumulating for millions of years, there lies the proof that our own solar system had crossed through a supernova debris field. The evidence is not a theoretical one. You can hold it in your own hand if you are able to drill deep enough. It is glowing with a radioactive decay. The isotope is iron 60. This form of iron is containing 26 protons and 34 neutrons in its nucleus, which is making it unstable. It is decaying with a half-life of 2.6 million years, and it is releasing radiation as it is transforming into the more stable elements. Iron 60 is not forming on the Earth naturally. It cannot be being produced by the normal stellar processes in our own sunday. The only way to be creating the significant quantities of this isotope is in the heart of a supernova explosion. The scientists had discovered the Iron 60 by accident in the 1990s, while they had been studying the deep-sea ferromanganese crusts. These formations are growing incredibly slowly on the ocean floor, and they are accumulating the layers of the metal compounds at the rates of just a few millimeters every million years. By slicing these crusts into the thin layers and then dating each of the layers by using the other radioactive isotopes like beryllium-10, the researchers were able to create a timeline that was showing how the chemical composition of the material that was falling from space had changed over the millions of years. Some of the layers had contained the normal amounts of iron, but others had had the concentrations of Iron 60 that were far above the background levels. The spikes were very sharp, which was indicating that the Iron 60 had arrived during the specific time periods rather than continuously. When the scientists had dated those layers, they had found two distinct peaks. The first of them had occurred roughly 2 million years ago, give or take a few 100,000 years. The second had happened around 7 million years ago, with a similar level of uncertainty. The numbers had matched perfectly with the predictions about when the supernovae that had created the local bubble would have expelled their debris and when the Earth would have passed through that expanding cloud of the radioactive material. The fit was too precise to be a coincidence. The scientists had found the physical proof that the Earth had travelled through the aftermath of the nearby stellar explosions. But Iron 60 is not the only isotope. The researchers had later found manganese 53 inches the same layers, which is another element that is being produced primarily in the supernovae. They had discovered plutonium-244 as well, which also cannot be forming on the Earth naturally. The multiple isotopes had strengthened the case. These were not just measurement errors or some kind of contamination. The radioactive atoms had genuinely fallen from space during those specific time periods. The discovery had answered some of the questions, but it had also raised some others. How much radiation had the Earth received during those passages through the supernova debris? The Iron 60 itself is not particularly dangerous because it had arrived in some very tiny amounts. There were a few atoms here and there, and they were spread out across the entire planet. But the presence of the Iron 60 is an indication that the whole debris cloud had passed over the Earth, and that cloud would have been containing the other particles as well. There would have been the high-energy cosmic rays, the gamma radiation, and the X-rays. All of this would have been bombarding the atmosphere of the Earth. Some of the scientists had suggested that this radiation could have had an effect on the life on the Earth, and that it could have increased the mutation rates, and it could have disrupted the ecosystems, and it could have possibly even contributed to the extinction events if the radiation dose had been high enough. But the evidence is remaining unclear. Life on our planet had obviously survived. No major extinction events are lining up perfectly with the peaks of the Iron 60. Either the radiation was not intense enough to be able to cause any catastrophic damage, or the magnetic field and the atmosphere of the Earth had been able to shield the surface effectively enough to be able to prevent a disaster. More recently, the researchers have found some similar Iron 60 deposits in the Antarctic snow on the Moon and in the cosmic dust that has been collected by the high-altitude aircraft. The isotope is continuing to be raining down on us even now, though it is doing so in some smaller amounts than it was during the peak periods. This is suggesting that we are still interacting with the remnants of those ancient explosions, and that we are still passing through the outer edges of the debris field even millions of years later. The radioactive evidence is proving something that is very important. The Earth is not an isolated place. We are traveling through the galaxy, and the galaxy is leaving its marks on us. The The supernova explosions that had created our local cosmic environment had not just happened somewhere that was far away, they had touched the Earth directly. Their fingerprints are remaining in our soil, in our oceans, and they are possibly even in our DNA, if the radiation had influenced the process of evolution during those particular periods. We are in a very real sense made from the ashes of the dead stars, and we are carrying the proof of the violence that had shaped our own neighborhood in the radioactive atoms that are still decaying in the crust of the Earth. Right now, the Earth is flying through a cloud. But this is not a weather cloud. It is an interstellar cloud, and it is made of hydrogen, helium, and some trace amounts of the heavier elements. This cloud is surrounding our entire solar system, and it is wrapping us in a cocoon of warm gas that is extending for several light years in every single direction. Scientists are calling it the local interstellar cloud, and it is moving. The cloud itself is measuring about 30 light years across, though its exact boundaries are remaining a bit fuzzy because the densities of the gas are gradually decreasing toward the edges rather than just stopping abruptly. The temperature is sitting at around 7,000 degrees Kelvin, which sounds very hot, but it is qualifying as being merely warm by the interstellar standards. The density is measuring at 0.3 of an atom per cubic centimeter. For a point of comparison, the air that you are breathing is containing about 30 billion atoms per cubic centimeter. This cloud is almost completely empty, yet it is still 300 times denser than the local bubble that is surrounding it. Here is where things get interesting. The cloud is moving relative to our solar system at a speed of about 16 miles per second. But the solar system is also moving relative to the galaxy at a speed of around 140 miles per second. When you are combining these two motions, you are getting something that is called the local interstellar wind. This is a flow of gas that is streaming through our solar system at a speed of roughly 16 miles per second, and it is coming from the direction of the constellation Ophiuchus. This wind is not blowing like the air on the Earth. Space is too empty for the fluid dynamics to be working in the same way. Instead, the individual atoms and the ions are flowing past our solar system like the rain that is falling through a moving car. Some of the particles are entering our heliosphere, which is the protective bubble that is being created by the solar wind. But most of them are flowing around the outside, and they are being deflected by the magnetic fields and the pressure that is coming from our own Sunday. Scientists have confirmed the existence of the local interstellar cloud by measuring the absorption of the light from the distant stars. When the starlight is passing through the gas, certain of its wavelengths are getting absorbed, and this is depending on what elements are present in the cloud. By analyzing these absorption patterns in the light from multiple different stars, the astronomers have been able to map out the location, the temperature, the density, and the chemical composition of the cloud. The cloud definitely exists, and we definitely live inside of it. The cloud is partially ionized, which means that some of its atoms have lost their electrons and are now carrying some electric charges. This ionization is happening because the ultraviolet light from the nearby stars is stripping the electrons away from the neutral atoms. These charged particles are then interacting with the magnetic fields, and they are creating some complex structures and flows that the ordinary neutral gas cannot produce. What is making the astronomers slightly nervous is the question of how long we have been inside of this cloud. The best of the estimates are suggesting that we had entered the local interstellar cloud sometime between 44,000 and 150,000 years ago, and this is depending on whose calculations you are trusting. That is an extremely recent event in the cosmic terms. Before that, we had been occupying a different region of the local bubble, and it had had possibly different properties for the gas, different densities and different temperatures. The cloud is moving through the local bubble, and so are we, but we are not moving in the same direction or at the same speed. Eventually, within another 10,000 to 50,000 years, and this is depending on which model you are believing, we will be exiting the local interstellar cloud, and we will be entering a different region. Maybe it will be another cloud, or maybe it will be just the empty space that is within the local bubble. The environment will change. The density of the gas that is around our solar system will shift. The amount of the interstellar material that is flowing into our heliosphere will either increase or decrease. Some researchers have suggested that these changes could have an effect on the climate of the Earth over some very long timescales. More of the interstellar gas that is entering the heliosphere might be compressing the protective bubble slightly, which would be allowing more of the cosmic rays to be able to reach the atmosphere of the Earth. Those cosmic rays could then be ionizing the atmospheric particles, and they could be potentially influencing the formation of the clouds and the climate patterns. The effects would be very subtle, and they would be far too weak to be able to cause an ice age or a mass extinction, but they might be strong enough to be able to show up in the long-term climate records. The local interstellar cloud is a part of a much larger structure, which is a complex of multiple different clouds, and they are all moving through the local bubble in different directions. These clouds have some names like the G cloud and the Ursa Major moving group. They are interacting with each other, and they are merging, and they are separating, and they are flowing around the obstacles that have been created by the stellar winds and the magnetic fields. Our solar system is swimming through this cosmic ocean, and the water is constantly changing. What lies ahead on our path through the galaxy, different clouds, different densities, and different unknowns are all waiting for us in the void. Wrapped around our solar system like a tilted crown there sits a ring of death. Some young, massive stars are burning there. These are stars that will explode within the next few million years. This structure is stretching for 3,000 light-years across, and it is tilted at an angle of 20 degrees relative to the galactic plane. Astronomers are calling it Gould's Belt, and it is surrounding us completely. The belt was discovered in the 1800s by Benjamin Gould, who had noticed that the brightest of the stars in our night sky are not distributing themselves evenly across the celestial sphere. Instead, they are clustering along a great circle that is tilted relative to the main band of light of the Milky Way. That circle is what is marking Gould's Belt, which is a ring of recent star formation that is containing thousands of hot young stars that are destined to die a violent death. The belt is including some of the most famous of the star-forming regions that are visible from the Earth. The Orion Nebula is sitting within it. So is the Scorpius-Centaurus Association, which is the same group of stars that was responsible for the supernovae that had created the local bubble. The entire structure is filled with the stellar nurseries, which are the places where the gas clouds are collapsing under their own gravity to be able to form the new stars. Even now, here is what is making it so unusual. Most of the star formation in the Milky Way is happening in the galactic plane where the gas and the dust are concentrating. But Gould's Belt is tilting at an angle of 20 degrees away from that plane, and it is creating a ring structure that is rising above and is dipping below the main stellar disk. Scientists are still debating how this structure had formed. The most popular of the theories is suggesting that a supernova explosion or a collision with a gas cloud about 30 million years ago had triggered a wave of star formation that had then expanded outward in a ring pattern, and that it had eventually created the structure that we are able to observe today. The stars that are in Gould's Belt are very young by the cosmic standards. Most of them are less than 30 million years old. Some of them are still forming right now, and they are wrapped in the cocoons of the dust and the gas. These are the O-type and the B-type stars, which are the hottest and the most massive of the stars in the entire galaxy. They are burning with a blue-white color, and they are radiating enormous amounts of ultraviolet light. They are consuming their fuel so quickly that they will be exhausting their nuclear cores within just a few million years, and then they will be detonating as a supernova. The belt is dangerous, not because it exists, but because it is changing. Star formation is continuing. New massive stars are lighting up inside of the ring. Each one of them is a ticking time bomb with a fuse that is measured in millions of years. When they are exploding, they will be feeding new energy into the surrounding space, and they will be possibly expanding the local bubble further and they will be potentially triggering new waves of star formation. Some of these stars have already died. We just have not seen the light from their explosions yet. A star that is 500 light-years away could have detonated 400 years ago, and the light from that blast is still traveling toward us through space. We would not know about it until the wavefront had arrived. Suddenly, a new point of light would appear in the night sky, and it would be bright enough to be able to be seen during the daytime, and it would be lasting for weeks or months before it was fading. The nearest of the massive stars in Gould's belt is currently sitting at a distance of about 400 light-years away. That is very close by the galactic standards. It is close enough that a supernova would be visible as a spectacular object in our sky, but it is far enough that the radiation would not be threatening the Earth directly. The real danger is coming from the stars that are within a few dozen light-years. At that distance, the gamma rays and the X-rays from the explosion could be having an impact on the atmosphere of the Earth, and they could be potentially depleting the ozone layer and be increasing the surface radiation levels. Astronomers are continuously monitoring the massive stars that are in our own neighborhood, and they are looking for the signs of the instability that might be indicating an imminent explosion. The stars are swelling as they are running out of their fuel. They are ejecting their mass in the powerful stellar winds. They are flickering, and they are dimming in the ways that are suggesting an internal chaos. So far, no stars in Gould's belt are showing any clear signs of exploding in the next few centuries, but the predictions are remaining uncertain. The stars can be surprising us. The belt is also containing dozens of the smaller star clusters and the associations. These are the groups of the stars that were born from the same gas clouds at roughly the same time. These clusters are drifting through space together, and they are gradually spreading apart over the millions of years as the individual stars are following the slightly different orbits around the galaxy. The Earth is not a part of any of these clusters. Our own sun had formed elsewhere, and it had probably done so 4.5 billion years ago in a completely different region of the galaxy, and it had then wandered here over the course of time. But now we are finding ourselves inside of Gould's belt, and we are surrounded by the stars that will be exploding long before our own sun is dying. We are living in a ring of fire, and that fire has not yet finished burning. Your own planet is existing inside of a bubble that has been blown by the Sunday. This bubble is protecting you from the galaxy. Without it, the interstellar radiation would be slamming into the Earth at its full intensity. The cosmic rays would be bombarding the atmosphere constantly, and the life as you are knowing it might never have been able to evolve. This protective shield is what is known as the heliosphere, and it has its limits. The sun is constantly spewing the charged particles out into space. There are the protons, the electrons, and the helium nuclei, and they are all being accelerated to the speeds of between 200 and 500 miles per second. This stream of the particles is what is known as the solar wind, and it is flowing outward in all directions, and it is filling the space that is around the sun with a hot, magnetized plasma. The solar wind is not stopping at the edge of the orbits of the planets. It is keeping on going, and it is expanding outward until something is stopping it. That something is the interstellar medium. All of the gas and the dust that is floating between the stars is creating a pressure that is pushing inward on our own solar system from every single direction. Where the outward pressure of the solar wind is equaling the inward pressure of the interstellar medium, a boundary is forming. This boundary, which is called the heliopause, is what is marking the edge of the heliosphere and the beginning of the true interstellar space. For decades, the scientists had been predicting where this boundary should be existing, and they had been doing so based on the theoretical models of how the pressure of the solar wind is decreasing with the distance, and how the interstellar pressure is pushing back. The calculations had suggested that the heliopause should be lying somewhere between 80 and 150 astronomical units from the Sun, though the exact distance had remained uncertain because we had not known precisely how dense the surrounding interstellar medium was. Then Voyager 1 had crossed it. On August 25th, 2012, At a distance of 121 astronomical units, Voyager 1 had detected a sudden drop in the particles of the solar wind, a sharp increase in the galactic cosmic rays, and a change in the direction of the magnetic field. The spacecraft had crossed the heliopause and it had entered the interstellar space. The measurements had confirmed that the boundary is existing exactly where the theory had predicted. But here is what had surprised the scientists. The heliosphere is not round. The early models had assumed that the solar wind would be creating a spherical bubble that would be expanding equally in all directions. The reality is much messier. The observations from the multiple spacecraft, including the Interstellar Boundary Explorer mission, had revealed that the heliosphere is asymmetric and that it is possibly teardrop-shaped or even more irregular. The shape is depending on the direction that the solar system is moving through the interstellar medium and on the local variations in the density of the gas and the strength of the magnetic field. The local interstellar cloud that is surrounding us is pushing on the heliosphere unequally. In the direction that we are moving, which is called the upstream direction, the heliosphere is compressing slightly, as our motion through the cloud is creating a ram pressure effect. In the opposite direction, which is the downstream side, the heliosphere is extending farther outward where the interstellar pressure is weaker. Some of the models are suggesting that a tail might be trailing behind us and that it might be being stretched out by our own motion through the galaxy, though this is remaining a debated topic. Inside of the heliosphere, the solar wind is shielding us from most of the interstellar particles and the galactic cosmic rays. These high-energy particles, which have been accelerated by the supernovae and the other violent events from all across the galaxy, are constantly bombarding our own region of space. Most of them are getting deflected, or they are being slowed down by the magnetic fields that are embedded in the solar wind. Only a fraction of them are penetrating all the way to the orbit of the Earth, and even fewer of them are making it through the magnetic field of the Earth to be able to reach the atmosphere. But the shield is not a perfect one. The activity of the Sun is varying on an 11-year cycle. During the solar maximum, when the Sun is producing more of the solar wind and some stronger magnetic fields, the heliosphere is expanding slightly, and it is blocking more of the cosmic rays. During the solar minimum, the heliosphere is shrinking, and it is weakening, and it is allowing more of the cosmic rays to be able to penetrate. The Earth is experiencing some measurable increases in the flux of the cosmic rays during these quiet periods, and the heliosphere is changing its size depending on what cloud we are passing through. When the solar system is traveling through the denser regions of the interstellar medium, the increased external pressure is compressing the heliosphere, and it is moving the heliopause closer to the Sunday. In the emptier regions, the heliosphere is expanding. The scientists are estimating that the heliopause could be moving inward by 20 or 30 astronomical units if we were to be entering a sufficiently dense cloud, which would be bringing the interstellar space significantly closer to the Earth. What would be happening if the heliosphere were to be shrinking too much? More of the cosmic rays would be reaching the Earth. More of the interstellar gas would be flowing into the inner solar system. The increased radiation could be affecting the satellites, the spacecraft, and it could be potentially even affecting the chemistry of the atmosphere. Some of the researchers have suggested that the major changes in the size of the heliosphere might be influencing the climate of the Earth over the millions of years. Though the evidence is remaining weak, what is certain is this: the shield that is protecting you is not a fixed one. It is breathing, it is flexing, and its strength is depending entirely on what it is that we are flying through in the galaxy outside. There is a line in space where our own sun is stopping being the dominant force. Beyond this line, the galaxy is taking over. Voyager 1 had crossed that line on August 25, 2012, and it had become the very first human-made object to be entering the true interstellar space. The crossing had happened at exactly 121 astronomical units from the Earth, which is roughly 11.3 billion miles away. The journey had taken Voyager 1 35 years. It had been launched in September of 1977, and the spacecraft had flown past Jupiter and then Saturn, and it had then headed toward the outer reaches of the solar system, and it had been carrying the messages from humanity in case it were to ever encounter any intelligent life. It had carried no more of the planetary objectives. Its mission had become purely to be exploring the boundary that is between the domain of the Sun and the galaxy that is beyond it. For the years before the crossing, the instruments of Voyager 1 had been detecting some changes. The levels of the cosmic rays had been gradually increasing as the spacecraft had been moving farther from the Sun and as the protective shielding from the solar wind had been weakening. The solar wind itself had been decreasing in its density and its pressure. The spacecraft was approaching something, though the scientists could not be predicting exactly when the boundary would be arriving. Then, in June of 2012, Voyager 1 had measured a rapid 9% increase in the flux of the cosmic rays over the course of just one single month. The increase had continued through July and August. Something dramatic was happening. On August 25th, the spacecraft had detected a sudden drop in the particles of the solar wind. Within just a few days, the count had fallen from about 25 particles per second to about 2 particles per second. Simultaneously, the galactic cosmic rays had increased very sharply. The direction of the magnetic field had shifted. Voyager 1 had crossed the heliopause. The influence of the Sun had ended. The true interstellar space had begun. But here is what had confused the scientists at first. The magnetic field had not changed as much as they had expected. The theory had predicted that inside of the heliosphere, the magnetic field would be being dominated by the Sun, and it would be carrying a specific orientation that was being determined by the solar activity. And outside of the heliosphere, the magnetic field should be shifting to be aligning with the local interstellar field, which would be coming from some completely different directions that were being determined by the galactic processes. The direction of the field had changed, but it had done so subtly. This had suggested that the local interstellar magnetic field might be being oriented similarly to the magnetic field of the Sun in that particular region of space. This was a coincidence that nobody had anticipated. Or perhaps the boundary region that is between the heliosphere and the interstellar space is much more complicated than the simple models had suggested, with some overlapping fields and some transition zones rather than a sharp divide. Voyager 2 had crossed the heliopause 6 years later in November of 2018 at a distance of 119 astronomical units. The crossing had confirmed what Voyager 1 had discovered, but it had also added some new puzzles. The two spacecraft had crossed at different distances, which was proving that the boundary of the heliopause is not a perfect sphere. It is wrinkling and it is shifting, and it is responding to the changes in the pressure of the solar wind and the variations in the surrounding interstellar medium. Both of the spacecraft are continuing to be transmitting their data even now, though their power sources are fading. The radioisotope thermoelectric generators that are providing their electricity are decaying, and they are producing less and less power each and every year. By the late 2025s or the early 2030s, both of the Voyagers will likely be stopping their functioning, and they will be falling silent as they are drifting deeper and deeper into the interstellar space, and they will be carrying their golden records with the recordings of the sounds of the Earth, the music, and the greetings in dozens of the different languages. Beyond the heliopause, the universe is a different place. The levels of the radiation are spiking. The temperature of the surrounding plasma is increasing from about 50,000 degrees inside of the heliosphere to some much hotter values on the outside. The density of the neutral atoms is changing. The Sun is becoming just another star. It is no longer the overwhelming gravitational and electromagnetic presence that it had been closer in. But even at 121 astronomical units, the gravity of the Sun is still dominant. The planets are orbiting closer than 50 astronomical units. The Kuiper belt is extending to perhaps 100 astronomical units. but the gravity is reaching much farther. The question is not whether the gravity of the Sun is extending beyond the heliopause, but rather where that gravity is stopping, being strong enough to be able to hold the objects in orbit. That boundary, where the objects are becoming more loyal to the galaxy than they are to the Sun, is lying far beyond where Voyager 1 had crossed into the interstellar space. That boundary is sitting at the very edge of the Oort cloud, and what is waiting there is making the crossing of the heliopause look like just stepping across a doorway. Out there at the true edge, the power of the Sun is finally dying completely. Imagine a sphere of frozen objects that is surrounding our own solar system. This sphere is extending from 2,000 astronomical units all the way out to 200,000 astronomical units from the Sunday. That is roughly 3 light-years in diameter, and it is reaching nearly halfway to the nearest star. Inside of this sphere, trillions upon trillions of icy chunks are orbiting in the darkness, and most of them are smaller than a city, and some of them are as large as the mountains. This is the Oort cloud, and we have never directly observed a single object that is inside of it. The existence of the cloud is inferred, not confirmed. We are seeing the comets that are entering the inner solar system from the random directions. They are not coming from the ecliptic plane where the planets are orbiting. They are not coming from the flattened disk of the Kuiper belt. These comets are arriving from above, from below, and from all sides equally, which is suggesting that they are coming from a spherical reservoir that is surrounding us. The math is working. The orbital mechanics is checking out. The cloud is almost certainly existing, but we cannot be seeing it directly because the objects are too small, too dark, and too far away to be reflecting enough sunlight for our telescopes to be able to detect. The astronomer Jan Oort had proposed the cloud in 1950 after he had been studying the orbits of the long-period comets. He had noticed that these comets were having the orbital periods of thousands or millions of the years, and that they were arriving from the seemingly random direction. Something had to be nudging them out of their distant orbits and be sending them sunward. Oort had calculated that a spherical cloud of the icy debris at the enormous distances could be explaining the observations. The idea had stuck. The cloud was named after him. Here is what is living in the Oort cloud. It is the leftover debris from the formation of our solar system 4.6 billion years ago, when the planets had been forming from the rotating disk of the gas and the dust around the young sun. Not everything had gotten incorporated into the planets. The small chunks of the rock and the ice had been flung outward by the gravitational interactions with Jupiter, Saturn, Uranus, and Neptune. Some of these chunks had escaped the solar system entirely. Others had not had quite enough speed to be escaping, but they had reached such distant orbits that they had barely remained bound to the Sunday. Over the billions of the years, these objects had spread out into a roughly spherical shell. The gravitational tugs from the passing stars, the tidal force from the Milky Way, and the random encounters had gradually circularized their orbits and had distributed them evenly around the solar system. The result is the Oort cloud that we are theorizing is existing today. The cloud is being divided into 2 regions. The inner Oort cloud, which is also called the Hills cloud after the scientist Jack Hills, who had proposed it in 1981, is extending from about 2,000 to 20,000 astronomical units. This region might be donut-shaped, and it might be concentrated around the ecliptic plane. It is denser than the outer cloud, and it is possibly containing tens or hundreds of times more of the objects, but it is still too sparse for any 2 of the comets to be close neighbors. Each of the objects is drifting alone in the dark, and it is separated from its nearest companion by the distances that are measured in the billions of the miles. The outer Oort cloud is extending from 20,000 to 200,000 astronomical units. This region is definitely spherical, and it is surrounding the entire solar system equally in all directions. The objects that are here are orbiting so slowly that a single trip around the Sun is taking millions of the years. Some of the comets in the outer cloud have never even completed one single orbit since they had arrived there shortly after the solar system had been formed. The estimates for the total number of the objects in the Oort cloud are varying wildly. The conservative estimates are suggesting that there are several trillion of the objects that are larger than half a mile across. The more optimistic estimates are reaching tens of the trillions. The total mass is probably being equal to a few times the mass of the Earth. It is maybe 5 to 10 Earth masses, if you are including everything down to the tiny pebbles, though this is remaining highly uncertain. These objects are pristine. They have not been being heated by the sun significantly since the formation of our solar system. They are containing the ice from the original molecular cloud that had collapsed to be forming our solar system. Studying them would be providing the direct evidence of what the early solar system had looked like, but we cannot be reaching them. The fastest of the spacecraft that has ever been being built, which is New Horizons, is traveling at about 36,000 miles per hour relative to the Earth. At that speed, reaching the inner edge of the Oort cloud would be taking roughly 500 years. Reaching the outer edge would be taking 30,000 years. So the Oort cloud is remaining a ghost. We are knowing that it is probably there. We are seeing its effects when the comets are falling inward toward the Sunday, but we cannot be touching it, and we cannot be photographing it, and we cannot be confirming its structure directly. It is sitting at the very edge of the gravitational dominance of the Sunday. These are the last of the objects that are still being bound to our own star before the galaxy is taking over completely. And something out there is shaking it. Something is disturbing those distant orbits, and it is sending the comets that are falling toward the Earth. What force can be reaching across the light years of the space and be shaking a trillion of the frozen chunks of the ice? The answer is lying in the galaxy itself. Between the outer planets and the spherical Oort cloud, there is sitting a structure that the scientists had predicted in 1981, but they are still not being able to directly observe. It is a donut-shaped swarm of the icy objects that are packed far more densely than the outer cloud is. This is the Hills cloud, and it is being named after the astronomer Jack Hills, and it might be explaining why the comets are keeping on falling toward the Earth, even after the billions of the years should have been emptying the outer Oort cloud. The problem is a simple one. The objects in the outer Oort cloud are orbiting so far from the Sun that their gravitational binding is very weak. A passing star, even one that is coming within a few light years, is exerting enough of the tidal force to be stripping the comets away or be sending them into the different orbits. Over 4.6 billion years, the outer cloud should have been being depleted significantly. The random encounters with the stars should have been scattering most of its contents across the entire galaxy. Yet the long-period comets are keeping on arriving. The supply is seeming to be nearly constant. Hills had proposed a solution. Maybe a denser reservoir is sitting closer to the Sun, and it is inside of the sphere of the outer cloud. This inner region would be being more tightly bound by the solar gravity, and it would be being less vulnerable to the disruption by the passing stars or the galactic tides. The objects in the Hills cloud could be surviving for the billions of the years, and they could be occasionally getting knocked into the outer cloud or directly into the inner solar system by the gravitational perturbations. The computer simulations had confirmed that the Hills cloud should be existing. When the researchers had been modeling the formation of the Oort cloud, and they had been tracking how the small icy objects had gotten ejected from the inner solar system by the planetary encounters, they had found that the objects had not just been flying directly outward into a spherical shell. Many of them had been settling into the intermediate orbits, and they had been forming a thick, donut-shaped structure that was being aligned roughly with the ecliptic plane. This inner cloud had naturally been emerging from the physics of the planetary migration and the gravitational scattering. The Hills cloud is probably extending from about 2,000 astronomical units to 20,000 astronomical units from the Sunday. Its thickness might be being several thousand astronomical units above and below the ecliptic plane. The density should be being tens or even hundreds of times greater than that of the outer Oort cloud. This is meaning that the majority of the cometary nuclei in the entire Oort cloud complex are actually residing in the Hills cloud rather than in the better-known outer sphere. Here is where the things are getting strange. A recent paper that had been being published in the early 2025 had suggested that the Hills cloud might not be being a simple donut. The researchers had been running the more detailed simulations, and they had found that the gravitational interactions with the planets, especially during the early solar system, when the planets were still being migrating, could be twisting the inner cloud into a spiral structure. Instead of a uniform ring, the Hills cloud might be looking more like a loosely wound spiral with the density variations that are depending on the angle and the distance from the Sunday. This spiral structure would be explaining some of the anomalies in the statistics of the long-period comets. The comets are not arriving perfectly uniformly from all of the directions as a purely spherical outer cloud would be suggesting. There are the subtle preferences, and there are the slight anisotropies that are hinting at an underlying structure. If the Hills cloud is having the spiral features, then those features could be biasing the directions from which the comets are eventually falling toward the Sunday. The Hills cloud is mattering because it is acting as a reservoir that is constantly replenishing the outer Oort cloud. As the objects in the outer cloud are getting stripped away by the passing stars, or they are being scattered by the galactic tides, the Hills cloud is feeding the new comets outward to be replacing them. Without this inner reservoir, the Oort cloud would have been being dispersed long ago, and the long-period comets would have been stopping arriving in the inner solar system billions of the years before the Earth had been developing the life. But the Hills cloud is also making our own solar system more vulnerable to the certain kinds of the disturbances. A star that was passing within a few light years might not be disrupting the Hills cloud significantly, but a star that was coming within 10,000 to 50,000 astronomical units and it was passing through or very near the inner cloud could be scattering the huge numbers of the comets simultaneously. Such an encounter could be triggering a comet shower, and it could be sending the hundreds or the thousands of the comets that are falling toward the inner solar system over a period of a few million years. Has this been happening? Possibly. Some of the researchers had been suggesting that the periodic comet showers might be correlating with the extinction events on the Earth, and that they might be being triggered by the stars that are passing through the Hills cloud and are sending the swarms of the comets inward. The multiple impacts over a short geological time span could be having the catastrophic effects on the climate and the biosphere of the Earth. The evidence is remaining controversial, but the physics is sound. The Hills cloud, if it is existing as it has been being predicted, is making our own solar system vulnerable to the stellar close encounters in a way that a purely spherical outer cloud would not. And nobody can be confirming any of this directly, because the Hills cloud is sitting far beyond where we can be sending the spacecraft, and it is far beyond where our telescopes can be detecting the individual objects. It is remaining theoretical, and it is being predicted by the models and the simulations, but it has never actually been being observed. It is a fortress that we are believing is protecting the outer Oort cloud, but we cannot be seeing it. And something is shaking that fortress. Something is reaching across the thousands of the astronomical units and is disturbing those frozen orbits. The galaxy itself is pulling on those comets. The Milky Way is trying to be tearing apart the Oort cloud, not violently and not quickly, but continuously and relentlessly. The gravity of the galaxy is squeezing and is stretching the outer solar system, and it is distorting the orbits of the comets that are at the very edge of the influence of the Sunday. This force is what is called the galactic tide, and it is the main reason why the long-period comets are falling toward the Earth. Think about how the Moon is creating the ocean tides on the Earth. The Moon is pulling harder on the side of the Earth that is closest to it than it is on the far side, because the gravity is weakening with the distance. This difference in the gravitational pull is stretching the Earth slightly, and it is creating a bulge of the water that is facing the Moon and another bulge on the opposite side. The tides are rising and are falling as the Earth is rotating through these bulges. The same principle is operating on the Oort cloud, but the forces are coming from the mass distribution of the Milky Way. The galactic disk is containing most of the visible matter of the galaxy, which are the stars and the gas that are packed into a flat structure. This mass is pulling on the solar system, but it is pulling harder on the side of the Oort cloud that is facing toward the galactic disk than it is on the side that is facing away. The difference in the pull is creating a tidal force that is stretching the cloud, but the galactic tide is more complicated than a simple tidal bulge. The mass of the Milky Way is not being concentrated at a single point like the Moon is for the Earth. The matter is being spread throughout the galactic disk, and the solar system is orbiting around the galactic center, and it is creating the additional forces. The astronomers are breaking the galactic tide into two main components. The radial component is pointing toward or away from the galactic center. This force is coming from the fact that the solar system is orbiting in a curved path around the galaxy. The objects in the Oort cloud that are on the side that is toward the galactic center are experiencing the slightly stronger gravity that is pulling them inward than the objects that are on the far side. This difference is creating a squeezing effect along the line that is pointing toward the galactic center. The vertical component is pointing perpendicular to the galactic plane. This force is resulting from all of the mass that is in the galactic disk that is pulling the objects toward the plane. The comets in the Oort cloud that are above the galactic plane are feeling a downward pull toward the disk. The comets that are below the plane are feeling an upward pull. This component is squeezing the Oort cloud along the axis that is perpendicular to the galactic disk, and it is stretching it along the other two axes. These tidal forces are incredibly weak. At the distance of the Earth from the Sun, the galactic tide is completely negligible. It is billions of the times weaker than the direct gravitational pull of the Sunday, but at the distances of 50,000 or 100,000 astronomical units where the comets of the Oort cloud are orbiting, the gravity of the Sun is weakening dramatically. At those distances, the galactic tide is becoming comparable in its strength to the gravity of the Sunday. The two forces are competing for the dominance. The competition is happening at a boundary that is called the tidal truncation radius. This is the distance from the Sun where the galactic tide is becoming strong enough to be permanently removing the objects from their orbit around the Sunday. Beyond this radius, the comets cannot be remaining bound to the Sun indefinitely. The tidal force will eventually be stripping them away, and it will be ejecting them into the interstellar space. The tidal truncation radius is sitting somewhere between 100,000 and 200,000 astronomical units, and it is defining the absolute outer edge of the Oort cloud. Here is how the galactic tide is sending the comets toward the Earth. Imagine a comet that is orbiting in the outer Oort cloud with a nearly circular orbit at about 50,000 astronomical units. The galactic tide is constantly tugging on this comet, and it is slightly changing its orbit over the millions of the years. Sometimes the perturbations are increasing the orbital energy of the comet, and they are pushing it outward toward the tidal truncation radius where it might be escaping. The other times the perturbations are decreasing its orbital energy, and they are causing its orbit to be becoming more elliptical. If the orbit is becoming elliptical enough, then the closest approach of the comet to the Sun, which is its perihelion, is dropping below a few dozen of the astronomical units. Suddenly, the comet is entering the realm of the giant planets. Jupiter, Saturn, Uranus, and Neptune can now be gravitationally interacting with it. These planets are scattering the comet further, and they are either ejecting it from the solar system entirely, or they are sending it into a shorter period orbit that is bringing it into the inner solar system, where we can be observing it. The galactic tide is not the only force that is acting on the cloud. The passing stars are also perturbing the orbits of the comets. The giant molecular clouds, which are the massive structures that are containing hundreds of the thousands of the solar masses of the gas, are occasionally passing within a few hundred of the light years of the solar system, and they are exerting the tidal forces of their own. But the galactic tide is constant. It is never stopping. It is always pulling, and it is always squeezing, and it is always reshaping the outer cloud. The scientists have calculated that the galactic tide alone can be explaining most of the long-period comets that we are observing. About half of the comets that are entering the inner solar system are likely owing their arrival to the galactic tidal perturbations rather than to the stellar encounters. The galaxy itself, through its gravity, is reaching across the light years of the space, and it is shaking the frozen chunks of the ice at the very edge of our solar system, and it is sending them that are falling toward the Sunday, and this process has been continuing for the billions of the years. It will be continuing for the billions more. The galaxy is patient. The galaxy is never stopping its pulling. Most of the Milky Way is invisible. The stars that you are seeing, the gas clouds and the dust, all of the normal matter that is emitting or is absorbing the light, is accounting for only about 15% of the total mass of the galaxy. The rest of it is the dark matter, and it is surrounding the entire galaxy in a massive halo that is extending for hundreds of the thousands of the light years into the space. The dark matter is not emitting the light. It is not absorbing the light. It is not interacting with the electromagnetic radiation at all, as far as the scientists can be telling. The only way that the dark matter is revealing itself is through the gravity. The astronomers had been discovering it by measuring how fast the stars are orbiting around the galactic centers. The speeds were too high. If the galaxies had been containing only the visible matter that we can be seeing, then the stars in the outer regions should be orbiting much more slowly. Just like the outer planets in our own solar system are orbiting slower than the inner planets because they are feeling the weaker gravity. But the stars are not slowing down. The galaxies are rotating almost like the solid disks, with the outer stars that are moving nearly as fast as the inner stars are. The only explanation is that the galaxies are containing far more mass than we can be seeing, and that mass must be being distributed in a large halo that is surrounding the visible disk. This invisible mass is providing the extra gravity that is being needed to be keeping the stars that are moving at the observed speeds without being flying off into the intergalactic space. The dark matter halo of the Milky Way is enormous. The computer simulations are suggesting that it is extending for at least 600,000 light-years from the galactic center, and that it is possibly being farther. The total mass might be being 10 times the mass of all of the visible stars, the gas and the dust combined. This halo is not an empty space. It is being filled with the dark matter particles. Whatever those particles are, they are being concentrated enough to be holding the galaxy together, but they are still being diffuse enough that the density is extremely low. Here is where it is affecting the solar system. The dark matter halo is contributing to the galactic tide that is acting on the Oort cloud. When the scientists are calculating the tidal forces that are squeezing and are stretching the outer solar system, they must be including two components. One of the components is coming from the visible matter in the galactic disk, all of the stars and the gas that we can be directly observing. The other component is coming from the dark matter halo. The contribution of the dark matter is adding about 15% to the total galactic tide. That might not be sounding like much, but at the distances of the Oort cloud, where the forces are extremely weak, 15% is mattering. It is meaning that the comets are getting perturbed slightly faster than they would be if only the visible matter were to be existing. The timescale for the orbital changes is shortening. The rate at which the comets are falling into the inner solar system is increasing. Some of the researchers have been suggesting that we might be being able to be detecting the dark matter directly in the solar system if its density is being high enough locally. The idea is that the dark matter particles, though they are not interacting with the light, might be interacting weakly with the normal matter through the other forces. The rare collisions that are between the dark matter particles and the atomic nuclei in the detectors on the Earth could be producing the measurable signals. So far, no dark matter particle has been being definitively detected despite the decades of the searching with the increasingly sensitive experiments. The null results are placing the strong limits on how the dark matter can be interacting with the normal matter. Either the dark matter is even more ghostly than had been being expected, and it is interacting through the forces that are so weak that we cannot yet be measuring them, or the dark matter is being composed of something that is more exotic than the theoretical models are currently predicting. But the dark matter is definitely existing. The gravitational evidence is overwhelming. The galaxies would be flying apart without it. The galaxy clusters would be dispersing. The large-scale structure of the universe, which is the web of the galaxies and the voids that we are observing on the largest of the scales, would not be forming correctly in the computer simulations without the dark matter that is providing the gravitational scaffolding. Something invisible is holding the universe together, and we are calling it the dark matter, even though we are not knowing what it is made of. For the Oort cloud, what is mattering is that this invisible halo is contributing to the forces that are pulling on the distant comets. The dark matter cannot be being ignored when we are calculating the orbital dynamics at the edge of our solar system. It is changing how quickly the galactic tide is disrupting the orbits. It is affecting where the tidal truncation radius is sitting. It is helping to be determining the boundary between what is remaining a part of the solar system and what is escaping into the galaxy. The recent studies have been suggesting something that is even stranger. The dark matter halo might not be being smooth. It might be containing the substructure, which are the smaller clumps and the streams of the dark matter that are moving through the galaxy. If one of these clumps were to be passing through the Oort cloud, then it could be gravitationally scattering the comets far more effectively than the smooth halo is doing. The encounter might be triggering a comet storm, and it might be sending the thousands of the comets that are plunging toward the inner solar system within a geologically short time span. Has this been happening? We are not knowing. The evidence for the dark matter substructure is remaining uncertain and being detecting. Such an event in the geological record of the Earth would be being extremely difficult, but the possibility is existing. The dark matter halo that is surrounding us is not just a uniform background. It might be containing the structures, the features, and it could possibly even be having the caustics where the density of the dark matter is spiking sharply. And if those features are passing through our own neighborhood, then they could be shaking the Oort cloud in the ways that we have not been experiencing for the billions of the years. Hidden in the dark matter halo that is surrounding the Milky Way are the sharp boundaries where the density is spiking by the orders of the magnitude. These boundaries are what are called the caustics, and they are forming naturally when the cold dark matter is falling into a galaxy. The caustics are existing as the surfaces in the three-dimensional space, and they are the places where the dark matter from the multiple directions is flowing together and is piling up. If a caustic is passing through the solar system, then it could be scattering the comets in the Oort cloud far more violently than the smooth background halo is doing. Here is how the caustics are forming. When the Milky Way had first been assembling billions of the years ago, the dark matter had been falling inward toward the center from all of the directions. This infall was not a smooth one. The dark matter had been coming in the streams and the flows, and they had been converging from the different angles. Where these flows had been intersecting, the density of the dark matter had been increasing sharply. The flows could not be passing through each other because the dark matter is collisionless. Instead, they had been piling up at the intersection points, and they had been creating the thin sheets of the enhanced density. These sheets are what are the caustics. The word is coming from the optics, where the caustics are describing the patterns of the focused light, like the bright lines that you are seeing on the bottom of a swimming pool when the sunlight is refracting through the rippling water. In the dark matter context, the caustics are the regions where the dark matter is being focused gravitationally. The density can be being 10, 100, and even 1,000 times higher inside of a caustic compared to the surrounding smooth halo. The caustics are forming the rings in the galactic plane. The first of the caustic rings is sitting closest to the galactic center, and it is maybe being 10,000 light-years out. The subsequent of the rings are being spaced farther apart, with the fifth of the rings that is possibly being sitting around 27,000 light-years from the center, and it is being close to the current location of the Sunday. Some of the research had been suggesting that we might actually be being inside of the fifth caustic ring right now, and that we might be being orbiting through a region of the enhanced dark matter density. If this is true, then it is having the implications. The local dark matter density would be being higher than the average, and it would potentially be making the dark matter detectors on the Earth more likely to be seeing the signals. The gravitational effects on the Oort cloud would be being stronger, and if the orbit of our solar system is taking us in and out of the caustic ring over the millions of the years, then the strength of the dark matter perturbations on the Oort cloud would be varying with the time. But the caustics are doing more than just being sitting there. They are moving. The rings are expanding outward over the cosmic timescales as the galaxy is evolving. A caustic ring that was moving through the solar system would be creating a temporary enhancement in the dark matter density that was lasting for perhaps a few 100,000 years as the ring was sweeping past. During that time, the extra gravitational pull from the caustic could be disturbing the comets of the Oort cloud more strongly than the normal. The scientists had been calculating what would be happening if a caustic were to be passing through the Oort cloud. The enhanced dark matter density would be gravitationally tugging on the comets, and it would be changing their orbits. The effect would not be being dramatic for most of the comets, because even the caustic dark matter is diffuse by the everyday standards. But at the edge of the Oort cloud, where the gravitational binding is already being weak, the extra perturbation might be being enough to be knocking some of the comets into the orbits that are bringing them toward the inner solar system. The probability of a noticeable effect is low, and it is maybe being 0.003% of a chance of being significantly affecting the flux of the comets during a caustic passage. But it is not zero. If the caustics are passing through the solar system every few tens of the millions of the years, then there is a chance that at least once or twice in the history of the Earth, a caustic encounter had been boosting the rate of the cometary impacts. Whether this had actually been happening and whether we could be detecting the evidence of it in the geological record is remaining an open question. The existence of the caustics themselves is remaining somewhat controversial. The prediction is coming from the simulations of the cold, dark matter halos, and some of the evidence from the motion of the stars in the Milky Way is suggesting that the caustic-like structures might be existing, but the dark matter detection experiments have not yet been confirming the presence of the caustics directly. If the dark matter is turning out to be being something other than the cold collisionless particles, then the caustics might not be forming at all. What is making the caustics particularly interesting is their sharpness. Unlike the smooth dark matter halo that is changing its density gradually over the thousands of the light years, a caustic is a surface that is just a few light years thick, where the density is jumping suddenly. Crossing a caustic would be being like crossing a boundary in the space where the gravitational conditions are abruptly changing. For the Oort cloud, this could be meaning entering a region where the dark matter tides are suddenly strengthening, and it would be lasting for the time that it is taking the solar system to be traversing the caustic sheet. No one is knowing if we are approaching a caustic now, and if we are moving away from one, or if we are nowhere near any of the caustic structures. The uncertainties in both the orbit of our solar system around the galaxy and the locations of the hypothetical caustic rings are too large to be making the precise predictions. We might be passing through a caustic tomorrow, or we might not be encountering one for 100 million years. The dark matter halo is keeping its secrets. It is pulling on us constantly and invisibly, and we cannot be seeing where its density peaks are hiding in the darkness. Above and below the galactic plane, and out beyond the thin disk of the stars where most of the visible matter is concentrating, the space is filling with the gas, and it is being heated to the temperatures that would be vaporizing any solid object instantly. This is the galactic halo gas. and it is a diffuse plasma that is being spread across the hundreds of the thousands of the light years, and it is glowing faintly in the X-rays. The temperature is reaching 1 million degrees Kelvin or more, and it is being hot enough to be stripping the electrons from the atoms and be creating a soup of the charged particles that is interacting with the magnetic fields in complex ways. This hot halo is not the same as the dark matter halo. The dark matter halo is invisible, and it is being spread even farther into the space. The hot gas halo is the normal matter, and it is mostly being hydrogen and helium with the traces of the heavier elements. But it is so hot and it is so diffuse that it is emitting very little of the visible light. Only the X-ray telescopes can be detecting it by observing the high-energy photons that are being produced when the electrons in the hot plasma are decelerating or are transitioning between the energy levels in the ionized atoms. The mass of the hot halo is enormous. This gas is representing much of the missing baryonic matter of the galaxy, which is the normal matter that the theoretical models had been predicting should be existing, but that the astronomers could not be finding for the decades. The problem was that they had been looking in the wrong wavelength. The gas is not emitting the visible light because it is too hot. You are needing the X-ray vision to be seeing it. Where is the heat coming from? There are two main sources. The supernova explosions in the galactic disk are injecting the enormous amounts of the energy into the surrounding gas. The shock waves from these explosions are heating the gas to the millions of the degrees, and they are blasting it upward out of the disk into the halo. This is creating what the astronomers are calling a galactic fountain. The hot gas is rising, and it is cooling as it is traveling, and it is eventually falling back down toward the disk under the gravity, where it is getting heated and is being blasted upward again. The cycle is repeating continuously. The second source is the gravitational energy. As the Milky Way had been forming, the gas had been falling inward toward the center, and it had been converting the gravitational potential energy into the kinetic energy and the heat. This accretion heating can be raising the temperatures of the gas to the millions of the degrees. Even now, the galaxy is continuing to be accreting the gas from the intergalactic medium, and this fresh gas is getting heated as it is falling into the potential well of the gravity of the galaxy. The hot halo is not a uniform thing. It is having the structure, and the temperature and the density are varying, and they are depending on the location. Near the galactic plane, where the supernovae are exploding most frequently, the gas is hotter and it is more turbulent. Farther above and below the plane, the gas is cooling slightly and it is becoming smoother. But everywhere the temperature is staying above a few 100,000 degrees, and it is keeping the gas ionized, and it is making it invisible to the normal optical telescopes. The recent X-ray observations had been revealing the giant bubbles in the hot halo that are extending for the thousands of the light years above and below the galactic center. These bubbles, which had been being detected by the Rosetta telescope, are appearing to be being the shock-heated regions that have been being created by the past activity in the central black hole of the Milky Way. Millions of the years ago, and it was perhaps being 10 to 20 million years back, the central black hole might have been being more active, and it might have been accreting the matter and be blasting the jets of the energy that were perpendicular to the galactic plane. Those jets had been inflating the enormous bubbles in the surrounding halo gas, and we are still seeing the remnants today. The hot halo is interacting with everything that is passing through it. The high-velocity clouds, which are the chunks of the cold gas that are falling toward the galaxy, are plowing through the hot halo and are creating the shock fronts. The stellar streams, which are the trails of the stars that have been being ripped from the disrupted satellite galaxies, are moving through the halo and are experiencing the drag from the diffuse gas. Even our own solar system is interacting with the halo, though we are being too close to the galactic plane to be feeling the significant effects from the hottest regions that are above and below us. For the objects that are far above or below the galactic plane, the hot halo is dominating the environment. The globular clusters, which are the ancient spheres of the stars that are orbiting through the halo, are swimming through this million-degree plasma continuously. The dwarf galaxies on the outskirts of the Milky Way are experiencing the ram pressure as they are moving through the halo gas, and they are stripping away their own gas and are leaving the trails behind them like the comets. The halo gas is also containing the metals, which are the elements that are heavier than the helium. These metals had been being produced inside of the stars through the nuclear fusion, and they had then been being ejected into the space when those stars had been exploding as the supernovae or had been losing their outer layers in the stellar winds. The presence of the metals in the hot halo is proving that the material from the galactic disk is getting transported outward and upward into the halo, and it is mixing the material that has been being enriched by the stellar processes throughout the vertical extent of the galaxy. The scientists are estimating that the halo gas will be remaining hot for the billions of the years. The cooling processes are existing, but they are operating very slowly at such low densities. The gas is radiating the energy as the X-rays, but the cooling timescale is longer than the age of the universe at the densities that are being found in most of the halo. Only in the densest regions that are near the galactic plane is the gas cooling enough to be falling back and be replenishing the disk. This hot halo is a part of the answer to what is lying above and below our own solar system. If you are going far enough up or down, then you are leaving the comfortable realm of the stars, and you are entering a zone that is being dominated by the invisible dark matter and the hot, glowing plasma. It is a realm where the temperatures are soaring, but the densities are plunging so low that you could be traveling for the light years without being encountering enough of the atoms to be filling a thimble. It is a realm where the rules are changing and where the true structure of the galaxy is revealing itself. In December of 2020, the astronomers who were using the Rosetta X-ray telescope had been discovering something terrifying. Two enormous bubbles are extending for 14,000 light-years above and below the galactic center. 14,000 light-years. That distance is half of the radius of the visible disk of the Milky Way. These bubbles are glowing with the X-ray light that is invisible to the human eyes, and they are marking the regions where the gas had been being shocked and being heated to the temperatures that are exceeding 2 million degrees. The bubbles are nearly symmetrical, with one that is above the galactic plane and one that is below. Their edges are sharp, and they are tracing the collisionless shocks where the hot gas is slamming into the cooler surrounding material. The southern bubble is including a structure that the astronomers have been puzzling over for the decades. It is being called the North Polar Spur, and it is a massive arc of the radio and the X-ray emission that is being visible from the northern hemisphere of the Earth. Nobody had been realizing until Rosetta that the North Polar Spur is just one single edge of a galaxy-scale bubble. What had been creating these monsters? There are two possibilities that are existing: either a burst of the star formation in the galactic center or the activity from the supermassive black hole. Both of these processes can be injecting enough of the energy to be inflating the bubbles that are this large. The scientists are estimating that the total energy that is being required is being equal to about 100,000 of the supernovae that are exploding in a relatively short time, or 1 million of the solar masses of the material that is falling into the central black hole and is converting a fraction of that mass into the radiation and the kinetic energy. The timing is appearing to be being millions of the years ago, and it is possibly being 10 to 20 million years back. The bubbles are not being expanding rapidly now. They are appearing to be being in a late stage of their evolution, and they are coasting outward very slowly as they are aging. The shock fronts at their edges have been weakening compared to what they must have been being initially. But the structure is persisting, and it is being visible across the thousands of the light years, and it is marking one of the most violent events in the recent history of the Milky Way. The bubbles are interacting with everything that they are encountering. The high-velocity clouds that are straying too close are getting accelerated, or they are being disrupted by the shock fronts. The magnetic fields in the galactic halo are getting compressed, and they are being amplified along the walls of the bubbles. The cosmic rays, which are the high-energy particles that have been being accelerated by the shocks, are streaming along the edges of the bubbles and into the surrounding space. Some of these cosmic rays might eventually be reaching the Earth. The scientists had been comparing the X-ray bubbles to the structures that had been being seen in the other wavelengths. The gamma-ray telescopes had previously been detecting the similar bubbles which had been being called the Fermi bubbles, and they had been being named after the Fermi Gamma-ray Space Telescope. The Fermi bubbles are aligning almost perfectly with the Erossiter X-ray bubbles, and this is confirming that they are the same structures that are being seen in the different types of the light. The radio telescopes are also detecting the emission from the bubble regions, and they are revealing the presence of the magnetic fields and the relativistic particles. What is making the discovery significant is the scale. These are not the local features. These are the galaxy-wide structures that are demonstrating that the central region of the Milky Way can be producing the outbursts that are powerful enough to be affecting the entire halo. If you were to be living on a planet in a star cluster that was being located above the galactic plane and it was being inside of one of these bubbles, then your sky would be being bombarded with the radiation from the shock-heated gas. The life would be facing the challenges that the Earth had never been experiencing. The bubbles are also revealing the information about the history of the galactic center. The central black hole of the Milky Way is quiet now. It is accreting the material very slowly, and it is producing the relatively little radiation compared to the active galactic nuclei in the other galaxies. But the bubbles are proving that our own black hole was not always being dormant. At some point in the past 10 million years, something had been feeding the beast. A gas cloud had been falling in, or the stars had been venturing too close and had been getting torn apart, or perhaps a smaller galaxy had been merging with the core of the Milky Way. Whatever had been happening had been unleashing enough of the energy to be blasting the gas for 10,000 light-years outward from the plane. The violence was extraordinary. The energy was staggering, and we are seeing the evidence that is still glowing above and below us, and it is marking the spot where the heart of our own galaxy had been exploding. The bubbles will be fading eventually, as the gas is cooling and is dispersing, but for now they are remaining the giant scars in the halo that are marking the ancient trauma. For 70 years, the astronomers had been staring at a massive arc of the radio and the X-ray emission that was stretching across the northern sky, and they had been arguing about what it was. Some of them had been saying that it was a nearby supernova remnant, and that it was maybe being a few hundred of the light years away. Others had been claiming that it was a distant galactic structure that was being thousands of the light years from the Earth. Nobody could be agreeing. The feature had been being called the North Polar Spur, and it had been dominating the radio sky above the galactic plane. The spur is extending for more than 100 degrees across the sky when it is being viewed from the Earth. That angular size could be meaning a small object that is nearby or a massive structure that is far away. The distance measurements had been being impossible because the spur is not containing the stars or the other objects with the measurable parallax. It is just the gas that is glowing in the radio waves and the X-rays with no clear indicators of how far away it is sitting. Some of the researchers had been favoring the local supernova explanation. They had been calculating that a star that was exploding about 30,000 to 100,000 years ago at a distance of a few hundred of the light years could be creating a shock wave that was expanding outward. By now, that shock wave would have been growing large enough to be appearing as an arc that was spanning a huge chunk of the sky. The X-ray emission would be coming from the shock-heated gas that was behind the expanding blast wave. Others had been pointing out the problems with the local scenario. The energy that was being required had been seeming to be too high for a single nearby supernova. The structure had been appearing to be too organized, and it had been being too smooth, and the orientation of the spur had been aligning suspiciously well with the galactic plane rather than being pointing randomly as a local supernova remnant should. These scientists had been arguing that the North Polar Spur must be being a part of a larger galactic structure, and that it could possibly be being associated with the central activity of the Milky Way or with the large-scale features in the halo. The Rosetta telescope had been settling the debate in 2020. The full-sky X-ray map had been revealing that the North Polar Spur is the southern edge of a massive bubble that is extending for 14,000 light-years above the galactic center. The spur is not a separate object at all. It is a part of the Rosetta bubbles that have been being described in the previous chapter. The mystery had been being solved by seeing the bigger picture. What had been looking like a local feature had been turning out to be a distant galaxy-scale structure. The confusion had been arising because the southern edge of the northern bubble is happening to be pointing roughly toward the Earth. When you are looking to the north from the position of the Earth, which is slightly above the galactic plane, then you are seeing the edge-on view of the shock front of the bubble. That edge is appearing as the North Polar Spur. The rest of the bubble is extending away from us, and it is being harder to be seeing because we are viewing it face-on rather than edge-on. The discovery had been resolving the decades of the arguments. The North Polar Spur is definitely being associated with the activity of the galactic center from millions of the years ago. The distance is being roughly 25,000 light-years to the origin point of the bubble that is near the galactic center, though the spur itself is being closer because it is representing the near edge of the expanding structure. The energy source was either the rapid star formation or the black hole activity, and both of which can be producing enough of the power to be inflating the bubbles of this magnitude. But the story is having a twist. The southern hemisphere is having a similar structure that is being called the South Polar Spur, though it is being less prominent when it is being viewed from the northern hemisphere of the Earth. This southern counterpart is a part of the Rosetta bubble that is extending below the galactic plane. Together, the two spurs are marking the edges of the giant bipolar outflow from the core of the Milky Way. The resolution of the mystery of the North Polar Spur is demonstrating how difficult it is to be determining the distances to the diffuse structures in the space. Without the clear distance indicators like the stellar parallax or the standard candles, the astronomers must be relying on the morphology, the energy requirements, and the associations with the other structures. Sometimes the answer is only becoming clear when a better telescope is revealing the full context. For the Earth, the true nature of the North Polar Spur is meaning that we are not inside of a nearby supernova remnant, as some had been fearing. We are simply viewing the edge of a much larger structure from our own vantage point in the galaxy. The radiation from the spur is being diluted by the distance, and it is posing no threat. But the structure is reminding us that the center of our own galaxy can be erupting violently, and it can be sending the shocks and the radiation for thousands of the light years outward. We are living in a dynamic galaxy. The calm that we are experiencing now is not being guaranteed to be lasting forever. Wrapped around the Milky Way like two donuts that have been being stacked above and below the galactic plane are the invisible magnetic field structures. These fields are following the rotation of the galaxy, and they are creating the toroidal patterns where the field lines are circling the galactic center in the closed loops. The fields in the northern toroid are pointing in one direction. The fields in the southern toroid are pointing in the opposite way. This asymmetry is telling us something fundamental about how the galaxies are generating the magnetic fields. The magnetic fields are being generated by the moving charged particles. In the galaxies, the combination of the rotation and the convective motions in the ionized gas is creating a dynamo effect that is similar to how the liquid iron core of the Earth is generating the magnetic field of our own planet. The galactic dynamo is operating on a much larger scale, and it is spanning the thousands of the light years, but the basic principle is remaining the same. The moving plasma is twisting the magnetic field lines, and it is amplifying them over the time until the field is reaching an equilibrium strength. The toroidal halo fields are sitting above and below the galactic disk, and they are extending for perhaps 1 to 2,000 light-years in each direction. They are existing separately from the magnetic fields in the disk itself, though the two components must be connecting somehow. The exact connection points and the transition zones are remaining poorly understood because mapping the three-dimensional magnetic field structures from our own position inside of the galaxy is extraordinarily difficult. The scientists are inferring the existence of the halo fields from the multiple observations. The polarized radio emission from the distant background sources is getting rotated as the radio waves are passing through the magnetized plasma in our own galaxy. This rotation, which is called the Faraday rotation, is providing the information about the strength and the direction of the magnetic fields along the line of sight. By measuring the Faraday rotation toward the thousands of the background sources in the different directions, the astronomers can be reconstructing the magnetic field structure of the galaxy. The data had been showing a clear pattern when they were looking to the north from the galactic plane toward the north galactic pole. The Faraday rotation had been indicating the magnetic fields that were pointing in one direction azimuthally around the galaxy. When they were looking to the south, the rotation had been indicating the fields that were pointing in the opposite azimuthal direction. This north-south asymmetry is a signature of the toroidal fields with the opposite orientations in each of the hemispheres. The field strength in the halo is weaker than it is in the disk. Where the disk fields might be reaching 5 to 10 microgauss, the halo fields are measuring at perhaps 1 to 3 microgauss. A microgauss is 1/1,000,000th of a gauss, and the magnetic field of the Earth at the surface is about half a gauss. So the galactic fields are extremely weak by the everyday standards. But when they are being integrated over the thousands of the light years, these weak fields can be having the significant effects on the charged particles and the cosmic rays. The toroidal fields are trapping the cosmic rays, which are the high-energy particles that have been being accelerated by the supernovae and the other violent events. The charged particles cannot be easily crossing the magnetic field lines. They are spiraling around the field lines, and they are remaining trapped in the halo for the extended periods before they are eventually escaping into the intergalactic space. This confinement is increasing the time that the cosmic rays are spending in the galaxy, and it is raising their density, and it is increasing the probability that they will eventually be colliding with the gas or be reaching the Earth. The recent models had been suggesting that the toroidal halo fields might be extending farther than had previously been being thought. Instead of stopping at 1 or 2,000 light-years above and below the plane, they might be reaching 10,000 light-years or more, and they might be filling much of the volume where the Erosita bubbles are existing. The magnetic fields would be interacting with the bubble shocks, and they would be getting compressed and be being amplified along the walls of the bubbles. The existence of these ordered magnetic field structures on the galaxy-wide scales had been surprising the theorists when it had first been being discovered. The random turbulent motions in the interstellar medium should be tangling the magnetic fields into the chaotic knots with no large-scale organization. But the observations are clearly showing the coherent structures that are spanning the thousands of the light years. The galactic dynamo must be being more efficient at organizing the fields than the simple turbulence models had been predicting. For the objects that are in the galactic halo, these magnetic fields are mattering. The cosmic rays are getting channeled along the field lines. The charged particles are experiencing the forces that are perpendicular to their motion, and they are causing them to be drifting azimuthally around the galaxy. Even the neutral gas can be feeling the magnetic effects if it is being partially ionized with the magnetic pressure and the tension that are affecting its motion. And the fields are not being static. They are evolving as the galaxy is rotating and as the new dynamo activity is generating the fresh field. The simulations are suggesting that the toroidal structures might be flipping periodically over the billions of the years, with the northern field direction that is becoming the southern direction and vice versa. We might be observing the galaxy during one particular phase of a much longer magnetic cycle. The invisible magnetic donuts that are above and below us are a part of the galactic machinery that is shaping the environment of the halo. They are guiding the particles, and they are trapping the energy, and they are connecting the disk to the halo in the ways that the gravity alone cannot be explaining. You cannot be seeing them, you cannot be feeling them. But they are existing, and they are wrapping the galaxy in the electromagnetic architecture. Scattered throughout the space that is above and below the galactic plane are the ancient spheres of the stars that are called the globular clusters. Each of the clusters is containing hundreds of the thousands to the millions of the stars that are packed into a ball that is just tens of the light years across. They are orbiting through the galactic halo on the paths that are taking them far above and below the disk, and they are returning to be crossing the plane every few hundred of the million years. Some of the clusters are orbiting clockwise around the galaxy. Others are orbiting counterclockwise, and they are moving backward relative to the rotation of the disk. These are among the oldest of the objects in the entire Milky Way. The globular clusters had been forming more than 10 billion years ago in the early universe, when the Milky Way was still being assembling. The stars that are inside of them are containing very few of the heavy elements compared to our own Sun, because they had been forming before the generations of the supernovae had been enriching the galaxy with the metals. These are the population 2 stars, and they are the ancient relics from the youth of the galaxy, and they are still being burning slowly in the halo. About 150 of the globular clusters are orbiting the Milky Way. Most of them are sitting within 100,000 light-years of the galactic center, but a few of them are venturing much farther. The most distant of the known clusters is orbiting more than 200,000 light-years out, and it is well beyond the visible galactic disk, and it is out in the dark matter halo, where only the gravity is connecting it to the galaxy. At that distance, the orbital period of the cluster might be being several billion years. The clusters are not being orbiting in the galactic plane. Their orbits are being tilting at the random angles, and they are crossing through the plane twice per orbit, but they are spending most of their time either above or below it. This distribution is completely different from that of the disk stars, which are orbiting nearly in the plane itself. The globular clusters are belonging to the halo population, which are the objects that had been forming before the disk had been settling into its current flattened structure. About 40% of the globular clusters of the Milky Way are orbiting in a retrograde direction, which is meaning that they are moving opposite to the direction that the galactic disk is rotating. This backward motion is unusual. The disk stars are all orbiting in the same direction, which is prograde, because they had been forming from a rotating cloud of the gas that had been collapsing into a disk. The retrograde orbits are suggesting a different origin. Many of these backward-moving clusters had probably been forming in the smaller galaxies that the Milky Way had been capturing and been destroying billions of the years ago. The clusters had been surviving as the galaxies that had been hosting them were being torn apart by the tidal forces. The orbits of the globular clusters are not simple ellipses like the orbits of the planets. The gravitational field of the galaxy is more complex than that of a point mass, with the contributions from the disk, the bulge, and the dark matter halo all being pulling in the different directions, and it is depending on the location. The orbits of the clusters are precessing and are wobbling, and they are sometimes doing so dramatically. A cluster might be following a rosette pattern, and it might be looping around the galaxy along a path that is never quite repeating exactly. These clusters are passing through the different environments as they are orbiting. When they are crossing the galactic plane, then they are plunging through the denser regions that are filled with the gas, the dust, and the stars. The interactions with the giant molecular clouds can be gravitationally disturbing the clusters, and they can be stripping away their outermost stars and be gradually eroding them over the billions of the years. Some of the clusters are having the tidal tails, which are the streams of the stars that have been being stretched along their orbits, and they are marking where the gravity of the galaxy had been pulling the stars away. In the halo, which is far above or below the plane, the clusters are experiencing a different environment. The density is dropping dramatically. The stars are scarce. The gas is hot and it is diffuse. The The clusters are swimming through the million-degree halo plasma, and they are moving at hundreds of the miles per second, and they are experiencing the ram pressure as they are pushing through the thin gas. The pressure is weak, but it is not zero. Over the billions of the years, even the weak forces can be shaping the evolution of the clusters. The scientists are studying the globular clusters to be learning about the early Milky Way. The clusters are preserving the information about the initial conditions of the galaxy, and it is being locked in the chemistry and the motions of their ancient stars. By measuring the ages, the compositions, and the orbits of the clusters, the astronomers are reconstructing the assembly history of the galaxy. Which of the clusters had been forming in the Milky Way originally? Which had been coming from the accreted satellite galaxies? The answers are helping to be building a timeline of the galactic evolution. Some of the clusters are dying. They are losing the stars continuously through a process that is called the evaporation. The random gravitational encounters that are between the stars inside of the cluster are occasionally giving one of the stars enough of the energy to be escaping. That star is drifting away, and it is reducing the total mass of the cluster slightly. Over the billions of the years, this process can be completely disintegrating a cluster, and it can be spreading its stars across the halo as a diffuse stellar stream. The clusters that we are seeing today are the survivors. Many more of the clusters had probably been existing in the early Milky Way, but they have since been being dissolved. The survivors are either being massive enough, or they are orbiting far enough from the galactic center that the tidal forces have not yet been destroying them. They will be continuing to be orbiting for the billions of the years more. These are the ancient monuments to the violent youth of the galaxy, and they are floating in the halo that is above and below us. Painted across the galactic halo like the cosmic spaghetti are the long, thin trails of the stars. These stellar streams are marking the death sites of the dwarf galaxies and the globular clusters that had been venturing too close to the Milky Way. The tidal forces had been stretching them apart, and they had been pulling the stars from the leading and the trailing edges of the doomed objects, and they had been leaving the rivers of the stars that are flowing around the galaxy in the paths that are tracing their fatal orbits. The most famous of these streams is the Sagittarius stream. The Sagittarius dwarf elliptical galaxy is currently being cannibalized by the Milky Way. As it is orbiting our own galaxy, the stronger gravity of the Milky Way is pulling on the near side of the dwarf harder than it is on the far side. This difference in the gravitational force, which is the tidal force, is stretching the dwarf galaxy along its orbit. The stars are getting stripped from both of the ends, and they are forming a stream that is wrapping completely around the entire Milky Way. The Sagittarius stream is extending for more than 360 degrees around the sky. It is looping above the galactic plane, and it is crossing through it, and it is looping below, and it is crossing again. If you could be seeing the stream with your own naked eye, then it would be appearing as a faint band of the light that was encircling the entire celestial sphere. But the stars are too dim, and they are too spread out. Only the large surveys that are mapping the millions of the stars across the sky can be detecting the presence of the stream. Dozens of the stellar streams have been being discovered in the halo of the Milky Way. Each one of them is telling the story of a disrupted object. The GD1 stream is coming from a destroyed globular cluster. The Orphan stream is having an unknown origin, and its parent object is completely gone. The Helmi stream is marking an ancient dwarf galaxy merger that had been happening billions of the years ago. The new streams are continuing to be being discovered as the surveys are becoming more sensitive and are covering the larger areas of the sky. The stellar streams are valuable because they are tracing the gravitational field of the Milky Way. The stars in a stream are following the orbits that have been being determined by the mass distribution of the galaxy. By measuring where the stars of the stream are being located and how they are moving, the astronomers can be reconstructing the gravitational potential that they are orbiting within. This technique is providing the information about the dark matter. Most of the mass of the galaxy is the dark matter, and the streams are responding to its gravity, even though we cannot be seeing the dark matter directly. Some of the streams are showing the gaps or the clumps, which are the unexpected variations in the stellar density along their length. These features might be indicating the presence of the dark matter subhalos, which are the small concentrations of the dark matter that are passing through the stream and are gravitationally perturbing it. If this were to be being confirmed, then it would be providing the rare evidence for the dark matter structure on the small scales, and it would be testing the predictions of how the dark matter is clumping and is flowing. The streams are existing primarily in the halo because the disruption process is happening when the objects are orbiting through the outer regions of the galaxy. The objects in the disk would be being confused with the billions of the disk stars, which would be making the streams impossible to be detecting. But in the halo, where the background stellar density is low, the streams are standing out. They are the anomalies, and they are the linear structures in an otherwise sparse and roughly spherical distribution. The streams that are above and below the galactic plane are crossing through the different environments than the disk objects are experiencing. They are passing through the hot halo gas, the magnetic fields, and the dark matter halo. Their orbits are taking them far from the plane, and they are sometimes going hundreds of the thousands of the light years out, and then they are going back down through the plane and out the other side. Each of the crossings is exposing them to the different conditions. The process of creating a stream is taking the time. A dwarf galaxy is not being dissolving in a single orbit. It might be surviving the dozens or the hundreds of the orbits, and it might be losing a little bit of the mass each time that it is passing near the center of the Milky Way where the tidal forces are peaking. The older of the streams are the most dispersed. Their stars are being spread so widely that detecting them is becoming very difficult. The younger of the streams are tighter, and they are more coherent, and they are easier to be spotting. Not all of the streams are forming from the disrupted objects. Some of them might be being the birth streams, which are the groups of the stars that had been forming together and had been remaining loosely associated as they are orbiting the galaxy. These are harder to be distinguishing from the tidal streams unless you can be measuring the ages and the compositions of the stars. The birth streams would be containing the stars of the similar age. The tidal streams would be containing the stars with a range of the ages because the parent galaxy, or the cluster, had been forming the stars over an extended period. The stellar streams are proving that the Milky Way is a cannibal. Our own galaxy had been growing by eating the smaller galaxies over the billions of the years. The streams are the remnants, and they are the indigestible bones of the galaxies that we had been consuming. They are orbiting through the halo that is above and below us, and they are the ghostly rivers of the stars that are marking the ancient violence. And the process is continuing. The Milky Way is still being consuming the dwarf galaxies today. The new streams will be forming in the future. The cannibalism is never stopping. The Milky Way is having dozens of the satellite galaxies, which are the small dwarf galaxies that are orbiting around us like the moons that are around a planet. Most of them are containing only the millions of the stars compared to the hundreds of the billions of the Milky Way. They are the cosmic midgets, and they are barely qualifying as the galaxies at all, but their distribution is bizarre. Instead of being spreading roughly spherically around the Milky Way, as the theory had been predicting, they are clustering in a thin plane that is perpendicular to the galactic disk. This satellite plane, which is sometimes being called the disk of satellites, is measuring about 600,000 light-years across, but it is only being 30,000 light-years thick. It is standing nearly vertical relative to the stellar disk of the Milky Way. About half of the known satellite galaxies are orbiting within this structure, and they are all moving in roughly the same direction around the plane. The configuration is extremely unlikely to be occurring by chance. When the astronomers had first been noticing this pattern in the 1970s, many of them had been dismissing it as a fluke. With only a few of the known satellites at the time, the sample size had been being too small to be drawing the strong conclusions. But as more of the dwarf galaxies had been being discovered, the pattern had been persisting. The satellites are really being preferring a plane, and that plane is really being perpendicular to the disk. This is contradicting the expectations from the theory of the galaxy formation. The satellites should be orbiting randomly, and they should be being isotropically distributed around the host galaxy. Their orbits should be reflecting the chaotic merges and the interactions that had been building the galaxy over the billions of the years. A thin, planar distribution, especially one that is being perpendicular to the disk, is suggesting that something had been organizing their orbits, and nobody is knowing what. Several of the theories are attempting to be explaining the satellite plane. One of them is suggesting that the satellites are not the independent objects, but that they are rather the remnants of a larger galaxy that the Milky Way had been tearing apart billions of the years ago. The satellites would be the fragments of that destroyed galaxy, and they would still be following the orbits that were close to the original path of their parent galaxy. This could be creating a planar distribution naturally. Another of the theories is proposing that the satellite plane had been forming from a cosmic filament, which is a large-scale structure in the dark matter distribution that had been feeding the galaxies into the Milky Way from a preferred direction. If the satellites had been falling in along this filament, then they would be entering with the similar orbital orientations, and they could potentially be creating a plane. A third of the possibilities is involving the dark matter halo of the Milky Way. The recent research had been suggesting that the dark matter halo might be triaxial, and that it might be shaped like a football or an egg, rather than being spherical. If the halo is elongated perpendicular to the disk, then the satellites that are orbiting in that direction would be experiencing the different gravitational forces than the satellites that are orbiting in the other directions. Over the billions of the years, this could be preferentially preserving the satellites in the perpendicular plane, while it would be disrupting the satellites in the other orbits. Most of the puzzling aspect is the coherent rotation. The satellites are not just sitting in the plane, they are orbiting around it, and most of them are moving in the same direction. This is implying the angular momentum, which is a spin to the system as a whole. Where had that spin come from? The random infall should be producing no net rotation. The satellites should be orbiting both clockwise and counterclockwise in roughly equal numbers. The problem is not being unique to the Milky Way. The Andromeda Galaxy, which is our nearest large galactic neighbor, is also having a satellite plane. So are several of the other galaxies when they are being examined carefully. This is suggesting that the phenomenon is common and that it is a natural outcome of the processes of the galaxy formation that we are not yet fully understanding. The cosmological simulations are starting to be reproducing the planar satellite distributions in some of the cases, but the match between the simulations and the observations is remaining imperfect. For the Milky Way specifically, the satellite plane is extending far above and below the galactic disk. If you were to be traveling upward from the solar system perpendicular to the galactic plane, then you would not be encountering the satellite plane for the tens of the thousands of the light years. But if you were to be traveling sideways along a different perpendicular axis, then you would be intersecting the satellite plane much sooner because it is cutting across a different dimension of the space. The satellites themselves are dying. The tidal forces from the Milky Way are pulling them apart over the billions of the years, and they are stripping away their outer stars and are leaving the stellar streams like those that have been described in the previous chapter. Eventually, each of the satellites will be completely destroyed, and its stars will be absorbed into the halo of the Milky Way. The satellite plane will be fading as its members are disappearing. But for now it is persisting, and it is a perpendicular ring of the dwarf galaxies that is orbiting around us, and it is defying the easy explanation. The dark matter halo that is surrounding the Milky Way might not be aligning with the galactic disk. The recent evidence is suggesting that the halo is being tilted, and that it is possibly even perpendicular to the stellar disk. If this is true, then this is representing a major upheaval in the structure of the galaxy. Sometime in its past, a reorientation of the entire dark matter distribution had been occurring, while the stars had been continuing to be spinning in their original plane. Something massive must have been happening to be twisting the halo, The evidence is coming from the multiple sources. The measurements of the motions of the stars in the halo are showing the patterns that are being inconsistent with a spherical or an oblate dark matter halo that is being aligned with the disk. The stars are moving as if they are responding to a gravitational field that is being tilted relative to the disk. The precise mapping of the orbits of the satellite galaxies is also suggesting that the gravitational potential that they are orbiting within is not being symmetric around the rotation axis of the disk. The computer simulations can be reproducing the tilted halos under the specific conditions. If a large galaxy is merging with the Milky Way, then the merger can be depositing the angular momentum in a direction that is different from the existing rotation of the disk. The dark matter which is dominating the mass of the galaxy is responding to this new angular momentum by gradually reorienting itself. The stellar disk, which is being much lighter, cannot be reorienting as easily. It is staying put while the dark matter halo is tipping around it. The process is taking the billions of the years. The halo is not being flipping instantly. It is gradually precessing and is twisting with the different parts of the halo at the different distances from the galactic center, and they are reorienting at the different rates. Eventually, the entire halo is settling into a new configuration that is being perpendicular or highly inclined to the disk. The result is a galaxy with a completely misaligned dark matter distribution. The scientists had been proposing that the merger with the Sagittarius dwarf galaxy could have been triggering this tilting. Sagittarius is currently falling into the Milky Way, but it has been orbiting our own galaxy for the billions of the years, and it has been passing through the disk multiple times. Each of the passages is depositing the energy and the angular momentum into the halo. Over many of the orbits, this could have been being enough to be torquing the dark matter halo into a tilted configuration. The tilted halo is explaining several of the puzzles. The satellite plane that is being perpendicular to the disk is making more sense if the dark matter halo is also being perpendicular, because the satellites are responding primarily to the gravity of the dark matter. The unusual properties of some of the stellar streams which are appearing to be orbiting in the directions that are being inconsistent with a disk-aligned halo are also fitting better with a tilted halo model. But the idea is remaining controversial. Measuring the shape and the orientation of the dark matter halo from inside of the galaxy is extraordinarily difficult. The dark matter is not emitting the light, so we can only be inferring its properties from its gravitational effects on the stars and the gas. Those effects are subtle, and they are requiring the extremely precise measurements of the positions and the velocities of the stars across the large volumes of the halo. The recent papers had been suggesting that the tilt had been beginning 6 to 8 billion years ago, which is roughly half of the age of the Milky Way. Before that time, the disk and the halo had been being aligned as had been being expected. Something had been happening around that epoch that had been initiating the tilt. The disk had been starting to be tilting too, though it had been doing so more slowly than the halo. The inner regions of the galaxy where the stellar gravity is being strongest had been retaining some of the alignment. The outer regions had been tilting more dramatically. If the halo is indeed being tilted perpendicular to the disk, then it is changing our understanding of the structure of the galaxy. We cannot be assuming that the disk and the halo are sharing the same symmetry. The forces that are acting above and below the disk would be differing from the forces that are acting in the other directions. The gravitational potential is becoming more complex, and the objects that are orbiting through this tilted halo would be experiencing the unexpected perturbations. For the Oort cloud, a tilted dark matter halo might be affecting the long-term orbital stability. The comets at the edge of our solar system are orbiting in the local gravitational field, which is including the contributions from both the disk and the halo. If those two components are pointing in the different directions, then the net force is changing, and it is depending on where you are in the space. Some of the orbits of the comets might be being stabilized, while others might be being destabilized. The consequences are remaining unclear. The warped halo, if it is real, is proving that the galaxies are the dynamic structures. What you are seeing in the stars is not necessarily being reflecting what is existing in the dark matter. The two components can be evolving independently, and they can be being twisted by the ancient merges and the interactions into the configurations that are seeming to be impossible, but that are actually being representing the natural outcomes of the gravitational physics that is operating over the billions of the years. The galactic disk is not a closed system. The gas and the energy are escaping continuously, and they are being blasted upward and downward by the violent events in the star-forming regions. The multiple supernovae that are exploding in the same area within a few million years are creating the superbubbles that can be breaking through the disk entirely. When a bubble is breaching the surface, the hot gas is erupting into the halo like the lava from a volcano. The astronomers are calling these eruptions the galactic winds or the chimneys, and they are transporting the material for thousands of the light years above and below the galactic plane. The process is beginning in the regions of the rapid star formation. The dozens or the hundreds of the massive stars are forming in a single giant molecular cloud. These stars are producing the intense stellar winds, and they are blowing the gas away at the thousands of the miles per second. Within a few million years, the most massive of the stars are exploding as the supernovae. Each of the blasts is adding the energy to the expanding bubble that has been being carved by the stellar winds. The bubble is growing, and it is pushing aside the surrounding gas, and it is sweeping it into a dense shell. If the bubble is forming near the midline of the galactic plane, where the gas is the densest, then the shell is slowing down, and it is eventually stalling. The bubble is remaining trapped in the disk. But if the bubble is forming slightly above or below the midline, or if the multiple bubbles are merging, then the combined structure can be becoming buoyant, and it can be rising like a hot air balloon through the denser, cool gas of the disk. As the bubble is rising, it is encountering less of the resistance. The density of the gas is decreasing exponentially with the height above the plane. What had been starting as a difficult climb is accelerating into a breakout. The bubble is breaching the upper boundary of the disk, and it is erupting into the low-density halo. The hot gas is streaming outward at the hundreds or the thousands of the miles per second, and it is carrying with it the metals that had been being forged in the stars that had been creating the bubble. These galactic chimneys are being visible in the radio and the X-ray observations as the vertical structures that are extending from the disk into the halo. The gas that is inside is hot, and it is ionized, and it is being enriched with the elements that are heavier than the helium. The oxygen, the carbon, the nitrogen, and the iron, all of the products of the stellar nucleosynthesis are getting transported upward. Without this process, the metals would be remaining locked in the disk where they had been being formed. The halo would be being pristine, and it would be containing only the hydrogen and the helium from the Big Bang. But the observations are showing that the halo gas is containing the metals, and it is not having as much as the disk, but it is having more than it should be having if the winds had never been escaping. The galactic wind mechanism is explaining this enrichment. It is also explaining where the energy that is heating the halo gas is coming from. The supernovae in the disk are depositing the energy into the bubbles that are escaping into the halo, and they are heating and are stirring the hot coronal gas that is filling the space that is above and below. The Aquila supershell is one of the examples. This enormous structure is extending for at least 550 light-years into the halo, and it is being driven by the star formation and the supernovae in a region that is near the constellation of Aquila as it is being seen from the Earth. The Cygnus superbubble is another with a diameter of 450 light-years, and it has been being carved by the stellar activity in the region of Cygnus. These are the local examples, but the similar structures are probably being existing throughout the entire Milky Way. Wherever the vigorous star formation is occurring, the galactic winds are being bipolar. They are flowing both upward and downward from the disk, and they are creating a symmetry that is perpendicular to the plane. The outflows are following the paths of the least resistance, which are tending to be being along the vertical axis where the density of the gas is dropping the fastest. Some of the wind material is escaping the galaxy entirely, and it is being lost to the intergalactic space. The other of the material is falling back, and it is raining down onto the disk after the millions of the years, and it is completing a galactic fountain cycle. The escaped gas is carrying the angular momentum away from the disk. This momentum loss is affecting the rotation of the disk over the billions of the years. The simulations are suggesting that the galactic winds are playing a role in regulating the star formation by removing the gas that would otherwise be collapsing to be forming the new stars. The winds are also enriching the intergalactic medium with the metals, and they are seeding the space that is between the galaxies with the elements that can be being incorporated into the new galaxies that are forming later. For us in the solar system, the galactic winds are the distant phenomena. We are sitting too far from any of the major star-forming regions to be feeling the direct effects. But billions of the years ago, when our own sun had been forming, it might have been being born inside of a star-forming region that was similar to those that are creating the galactic winds. The early solar system could have been being bathed in the hot metal-enriched gas from the nearby supernovae. That gas had been contributing to the solar nebula from which the planets had been forming. The chimneys that are above and below us are carrying the blood of the galaxy into the space. They are transporting the matter and the energy from the dense fertile disk into the empty halo. They are connecting the visible galaxy to its invisible surroundings, and they are proving that what is lying above and below is not just the empty space, but a dynamic environment that is being shaped by the violence from below. When the scientists had been measuring the temperature of the hot gas that was inside of the local bubble by using the Rosetta X-ray telescope, they had been discovering something that nobody had been predicting. The gas is significantly cooler when they are looking toward the North Galactic Pole compared to when they are looking toward the South Galactic Pole. The difference is measurable, and it is repeatable, and it is completely unexplained. Nobody is knowing why the local bubble is having a temperature gradient. The northern side is measuring at roughly 700,000 degrees Kelvin. The southern side is reaching about 1 million degrees or slightly higher. That is a substantial difference, and it is nearly 50% hotter on one side than it is on the other. For a structure that is as large as the local bubble, which is spanning 1,000 light years, such a temperature asymmetry is suggesting that something had been creating the unequal heating between the two hemispheres. One of the possibilities is that the supernovae that had been creating the bubble had not been exploding symmetrically. If more of the stars had been exploding on the southern side, or if they had been exploding more recently on that side, then the gas there would have been being heated more intensely. The temperature difference would be a relic of the asymmetric explosion pattern that has been being frozen into the structure of the bubble. Another of the theories is suggesting that the surrounding interstellar medium was not a uniform thing before the bubble had been forming. The local bubble had been expanding into the pre-existing gas with the different properties in the different directions. If the gas to the south had been being denser, or it had been having a different composition, then it might have been responding differently to the shock waves from the supernovae, and it might have been resulting in the different final temperatures. A third of the possibilities is involving the recent activity. Perhaps a late supernova had been exploding on the southern side within the last few million years, and it had been adding the extra heat to that hemisphere without having the time to be equilibrating across the entire bubble. The temperature gradient would be being temporary, and it would be gradually evening out over the next 10 or 20 million years as the hot gas is mixing. The uncertainty about the cause is reflecting how poorly we are understanding even the nearby structures. The local bubble is surrounding us. We are living inside of it, yet we cannot be explaining its basic temperature profile. The problem is that we are seeing the bubble from only one vantage point, which is from the inside looking outward. We cannot be moving to a different location and be observing how the temperature is varying from the other directions. The temperature measurements are relying on being analyzing the X-ray spectra. The hot gas is emitting the X-rays with the energies that are depending on the temperature of the gas. By measuring which of the X-ray energies are being present and their relative intensities, the astronomers can be determining the temperature of the emitting gas. The Eurosita telescope had been observing the entire sky in the X-rays, and it had been creating a full sky temperature map of the interior of the local bubble. That map is clearly showing the north-south asymmetry. The feature is real, and it is not a measurement artifact or an instrumental effect. The multiple analysis methods are confirming that the gradient is existing. But what is creating it? Until we are developing the better models of the formation and the evolution of the superbubbles, or until we are discovering the additional observational clues, the temperature gradient is remaining a mystery. The asymmetry might be affecting how the bubble is expanding in the different direction. The hotter gas is having the higher pressure, and it is expanding faster. If the southern side is hotter, then it might be expanding more rapidly than the northern side is. This could be creating a lopsided structure, with the center of the bubble being offset from where the initial supernovae had been exploding. Over the time, the entire bubble might be drifting northward, as the hotter southern side is pushing it in that direction. For our own solar system, the temperature gradient is probably having no immediate consequences. We are sitting inside of the bubble, but we are being insulated from the direct exposure to the hot million-degree gas by the denser local interstellar cloud that is surrounding us. The cloud is acting as a buffer, and it is protecting the heliosphere from the extreme temperatures of the interior of the bubble. But the gradient is affecting the larger environment that we are inhabiting. If the future supernova explosions are occurring within the local bubble, then they will be interacting with the gas that is already having a temperature gradient. The new explosions might be amplifying the asymmetry, or they might be erasing it, and it would be depending on where they are occurring. The future evolution of the bubble is depending partly on its current temperature structure, which we are still not fully understanding. The unexpected temperature gradient is a reminder that the space is more complex than the models are predicting. Even the large-scale structures are showing the surprises when they are being examined closely. The local bubble has been being studied for the decades, yet only with the unprecedented sensitivity of the Eurosita telescope did the temperature asymmetry become clear. What other of the surprises are hiding in the data, and they are waiting for the better instruments to be revealing them? Every single second, hundreds of the high-energy particles are slamming into the atmosphere of the Earth from both above and below. These cosmic rays, despite their name, are not the rays at all. They are the atomic nuclei, and they are mostly being the protons, and they have been being accelerated to nearly the speed of light by the violent processes from all across the galaxy. They are raining down on the Earth continuously, and they are invisible and they are unstoppable. Where they are coming from and how they are reaching such enormous energies are remaining partially mysterious. The cosmic rays had been being discovered in 1912 by Victor Hess during the balloon flights into the upper atmosphere. He had been measuring the increasing levels of the ionizing radiation at the higher altitudes, and he had been proving that the radiation was coming from the space rather than from the Earth. The discovery had eventually been earning him a Nobel Prize. But more than a century later, the scientists are still debating the sources and the acceleration mechanisms for the highest of the energy cosmic rays. Most of the cosmic rays are coming from the supernova remnants. When a star is exploding, the blast wave that is expanding outward is accelerating the particles to the relativistic speeds. The shock front is acting like a cosmic particle accelerator, and it is bouncing the particles back and forth across the shock until they are gaining the enormous energies. This mechanism, which is called the diffusive shock acceleration, can be producing the cosmic rays with the energies up to about 100 trillion of the electron volts. But some of the cosmic rays are having the higher energies, and they are much higher. The most energetic of the cosmic rays that has ever been being detected had been hitting the atmosphere of the Earth with the energy that was being equivalent to a baseball that was traveling at 60 miles per hour, and it was all being concentrated in a single atomic nucleus. Nobody is knowing how the natural processes can be accelerating the particles to such ridiculous energies. The supernova remnants cannot be doing it. Even the most powerful of the sources in the galaxy are struggling to be explaining the highest of the energy cosmic rays. The cosmic rays are not being traveling in the straight lines from their sources to the Earth. The magnetic fields of the galaxy are deflecting the charged particles, and they are causing them to be wandering through the space in the random zigzag paths. A cosmic ray might be traveling for the thousands of the light years through the galaxy, and it might be bouncing around the magnetic field structures before it is eventually reaching the solar system. By the time that it is arriving, its direction of the motion is no longer being pointing back toward its source. The particle has been losing all of the memory of where it had come from. This is making identifying the sources very difficult. The astronomers can be detecting where the cosmic rays are arriving from, but those arrival directions are being randomized by the magnetic fields. Only at the very highest of the energies, where the magnetic deflection is becoming weaker, can the cosmic rays be traveling nearly straight, and they could potentially be allowing their sources to be being identified. But the particles at those energies are extremely rare. The detectors are waiting for the years to be observing a single event. When the cosmic rays are hitting the atmosphere of the Earth, then they are colliding with the nitrogen or the oxygen nuclei, and they are creating the showers of the secondary particles. These showers are cascading down through the atmosphere, and they are multiplying with each of the collisions until the thousands or the millions of the particles are reaching the ground from a single cosmic ray. The detectors on the surface are measuring these showers, and they are reconstructing the energy and the type of the original cosmic ray from the properties of the shower. The flux of the cosmic rays is varying, and it is depending on the activity of the sunday. During the solar maximum, when the sun is producing the strong magnetic fields and the intense solar wind, fewer of the cosmic rays are penetrating to the Earth because they are getting deflected by the enhanced interplanetary magnetic field. During the solar minimum, the solar wind is weakening and the flux of the cosmic rays is increasing. The atmosphere of the Earth is experiencing about 20% more of the cosmic rays during the solar minimum than it is during the solar maximum. The cosmic rays are having the consequences. They are ionizing the upper atmosphere, and they are creating the electrical conductivity that is affecting the atmospheric chemistry. Some of the researchers had been suggesting that the cosmic rays might be influencing the formation of the clouds by creating the ionization that is helping the water vapor to be condensing. If this is true, then the variations in the flux of the cosmic rays could be affecting the climate over the long timescales, though the effect would be being subtle compared to the other climate drivers. The living organisms on the surface of the Earth are being protected from the cosmic rays by the atmosphere, which is absorbing most of the incoming radiation, but the astronauts in the space are receiving the much higher doses. On the International Space Station, the exposure to the cosmic rays is about 150 times higher than it is on the ground. On a trip to Mars, the exposure would be being even greater. The cosmic rays are representing one of the major health risks for the long-duration space missions. The cosmic ray background is also affecting the technology. The high-energy particles that are passing through the computer chips can be flipping the individual bits, and they can be causing the soft errors in the memory or the logic circuits. The spacecraft and the satellites are experiencing these errors regularly. The cosmic rays are creating the false signals in the detectors, and they are limiting the sensitivity of the astronomical instruments. Even the elections have been being blamed on the cosmic rays when the voting machines had been malfunctioning. Above and below our solar system, the cosmic rays are filling all of the space. They are arriving from every single direction, and they have been being accelerated by the supernovae, the pulsars, the supermassive black holes, and they could possibly be coming from the other sources that we have not been identifying. They are carrying the information about the most violent of the processes in the entire galaxy. And they are raining down on us constantly, and they are the invisible travelers from the depths of the space. And they are bringing the energy from the explosions that had been happening thousands of the years ago in the places that are thousands of the light years away. There is a line in the space beyond which nothing can be remaining bound to the Sunday. Not the planets, and not the comets, and not the spacecraft. At this boundary, the gravity of the Milky Way is becoming stronger than that of the Sunday. The objects that are beyond this line are belonging to the galaxy and not to our own solar system. This is what is called the tidal truncation radius, and it is what is marking the absolute edge of the gravitational dominance of our solar system. That edge is sitting somewhere between 100,000 and 200,000 astronomical units from the Sunday. The boundary is existing because the gravity is weakening with the distance. Close to the Sun, the solar gravity is dominating overwhelmingly. The Sun is pulling on the nearby objects far more strongly than the galaxy is doing. But if you are moving outward, then the pull of the Sun is weakening rapidly. Meanwhile, the tidal forces of the galaxy are staying roughly constant because the scale of the galaxy is so much larger than that of the solar system. At some distance, the two forces are becoming equal. Beyond that distance, the galaxy is winning. What is happening at the tidal truncation radius? The objects that are orbiting the Sun at that distance are feeling the equal gravitational tugs from both the Sun and from the galactic tide. Their orbits are becoming unstable. The small perturbations which closer in would be causing only the minor orbital changes are now being able to be ejecting the objects entirely. Over the millions of the years, the galaxy is stripping away any of the objects that are orbiting near or beyond the truncation radius. This is why the Oort cloud is having an outer edge. The comets cannot be surviving beyond the tidal truncation radius for the billions of the years. The galaxy is removing them. The outer boundary of the Oort cloud, which is at roughly 200,000 astronomical units, is coinciding with where the tidal truncation radius is being calculated to be. It is not a coincidence. The galaxy itself is defining where our own solar system is ending. The exact location of the boundary is depending on which direction you are looking. Toward the galactic center, the tidal forces are slightly stronger, and they are bringing the truncation radius closer. Away from the galactic center, the tidal forces are weakening slightly, and they are allowing the boundary to be extending farther. The Oort cloud is not a perfect sphere. It is slightly elongated, and it is being stretched along the line that is pointing away from the galactic center, where the solar gravity can be holding the objects at the greater distances. Calculating the tidal truncation radius is requiring us to be knowing the mass distribution of the galaxy, and it is including both the visible and the dark matter. The uncertainty in the properties of the dark matter halo is translating directly into the uncertainty in where the boundary is sitting. The different models are placing it anywhere from 100,000 to 200,000 astronomical units, which is a factor of 2 range that is reflecting our incomplete knowledge of the galactic structure. Beyond the tidal truncation radius is lying the interstellar space. And it is not just in the sense of being outside of the heliosphere, but in the deeper sense of being outside of the gravitational domain of the Sun. The objects that are there are not being orbiting the Sunday. They are orbiting the galactic center, and they are being influenced primarily by the galactic gravity. If the Sun is having the objects that are beyond the truncation radius, then they are not being a part of the solar system anymore. They are the independent interstellar objects that are happening to be passing near the Sun temporarily. The concept is applying to all of the stars. Every single star is having its own tidal truncation radius, beyond which the galaxy is dominating. The stars that are in the dense regions near the galactic center are having the smaller radii because the nearby stars are contributing the additional tidal forces. The stars in the halo that are far from the galactic center are having the larger radii because the local tidal forces are being weaker there. The truncation radius of our own Sun is typical for a star at our own galactic location. Some of the scientists had been speculating that the Sun might have been having a much more extensive Oort cloud initially, and that it was perhaps being extending several times farther than it is doing now. The encounters with the passing stars and the gradual erosion by the galactic tides had been stripping away the outermost of the comets over the billions of the years. What is remaining is the inner core of the original cloud, which is the region that is close enough to the Sun that even after 4.5 billion years, the solar gravity is still holding it. The tidal truncation radius is representing the ultimate boundary. Beyond it, you are no longer being a part of the realm of the Sunday. You are belonging to the galaxy. Everything that is above and below our own solar system, all of the structures that have been being described in the previous chapters, is existing beyond this boundary, or it is spanning the scales that are far larger than it is. The local bubble is extending for 1,000 light years. The galactic halo is reaching for hundreds of the thousands of the light years. The dark matter is surrounding the entire galaxy. We are a tiny system that is being embedded in the structures that are vastly larger than ourselves. The gravitational influence of our own sun is extending for just 3 light years at the most. Beyond that, the galaxy is taking over completely. What is lying above and below our own solar system is not just the empty space. It is a galaxy-scale environment that is being filled with the hot gas, the magnetic fields, the dark matter, the cosmic rays, the stellar streams, and the ancient structures that have been being shaped by the billions of the years of the evolution. We are floating in that environment, and we are being protected by the distance and by the local dominance of the Sunday. But the boundary is there. The galaxy is surrounding us. And at the edge, the power of the sun is finally ending. The galaxy is waiting beyond.